Good morning, everyone. Thoughtworks welcomes you all for the Green Software Foundation Global Summit 2022. I, Garima Mittal, will be the host for the day. So, the summit aims to provide the educational content and the networking opportunities for the participants who are interested in sustainability and clean tech. Before we start, let's hear some meeting etiquette. So, first of all, be energetic and enjoy the sessions. People who are joined through Zoom, please be sure that if you have any questions, put in the Q&A sections only. And I hope my screen is correct. And people who are here in person, if you have any questions, you can note down in the notepads that has been provided to you. We'll take it at the end. And yes, people who are in the room, please put your phone on silent. So we'll start with the first talk, that is our initiation of the section. And let me also give you the agenda for the session. Tag lectures. Easy. Let me start it. So the first talk will be from Satish Vishwanathan. He is the head of Social Impact Thoughtworks India. And then we'll have a talk on then we'll have the next talk. Just give me 1 minute, by Andy Nolan. Then we'll have the next talk on the architecting and developing of lower resource utilization by Sri Ram Narayanan and server optimization by Kunal Madik. Then we'll have the most awaited panel discussion. And the panelists are in. She is the Director of Sustainability Zero, Australia. Elizabeth, she is the Executive Director, Sustainability Providence Healthcare USA. Daniel Fred, and he's the Green Tech Advocate, Thoughtworks Spain. Nagarjun Kundakaru will be the moderator for the session. And he is the Director of Emerging Services, Thoughtworks India. The next session will be by Kuldeep Singh. He is the Principal Consultant, Thoughtworks India, and the session will be on sustainability and extreme reality. Then we will having another session by Razin Memon and Srinivasan Raghunathan. Razin is the lead consultant and GSF India lead, and Srinivasan is the senior program manager, Microsoft India. And then we'll have a closing ceremony by Raman Kansan. So I welcome Satish Vishwanathan to please go ahead and start the talk.
Hello, folks. Good morning. Can everyone hear me all right?
Yes, Satish. Loud and clear. Thank you.
Okay, thank you. Thank you to the organizing team for giving me this opportunity. Good morning, everyone. It's my pleasure and great privilege to welcome you all to the inaugural Green Software Foundation Global Summit 2022. My name is Satish Vishwanathan, and I lead social impact for Thoughtworks in India. And in case you're wondering why a tech company needs a head of social impact, I thank you very much. I will use your curiosity to tell you a little bit about Thoughtworks and why we're hosting this summit. And I'll keep my remarks brief because we have a pretty exciting action-packed day ahead. So for those of you who may or may not know, Thoughtworks is a global consultancy. We integrate strategy, design, and software engineering to enable enterprises and technology disruptors across the globe to thrive as modern digital businesses. Right. And for close to about 30 years, we pushed the boundaries of technology to help clients achieve their ambitious missions. And we pioneered industry trends such as agile software development. And in fact, we count among our ranks some of the original signatories of the Agile Manifesto. And we've also been instrumental in creating open source projects that have revolutionized the industry with software such as Selenium for automated web testing, which is pretty much standard, as well as Cruise Control, which is the kind of ancestor of the current continuous integration systems that made rapid web development possible today, right? But throughout, I think as an organization, we've also had a really strong streak of thinking just beyond our financial bottom line. And this has taken on several forms over the years. We've started with social impact projects. We work with organizations primarily in healthcare and across the development sector. And our focus was on using technology to solve some of humanity's pressing problems, right? But I think it's also fair to say that we've gone just beyond throwing a bunch of people with tech skills at problems. And throughout, we've definitely recognized that tech is a very powerful tool, but it's still just a tool, right? And without deeply understanding the problems, without asking the right questions, and without standing in solidarity with those at the front lines, tech is just a shiny toy, right? And that's the deep recognition that we've come to over the years. And recognizing this fact, throughout, we've sought to build coalitions, we've joined movements, and we've forged partnerships to sustain changes and create lasting impact. And that's really what we're after as an organization, right? Now, hopefully that gives you a sense of who we are as an organization, and probably also gives you an inkling of why becoming one of the founding members of the Green Software Foundation was a very, very natural thing for us, right? The Green Software Foundation sits very neatly at the intersection of all of the things that we hold dear. It's an opportunity to use our privilege and skills as technologists. It's an opportunity to forge partnerships with other organizations and other leading technology organizations. It's an opportunity to create a movement for sustainable change in how software is built. And it's also an opportunity to build sustainability thinking into areas that have already and will continue to have a significant impact on climate change and carbon emissions, right? Though the Green Software Foundation was started just almost a year ago in 2021, it seems to have made rapid strides already. As Garima said in the introduction, the Green Software Foundation's vision is to change the culture of building software so that sustainability becomes a core concern of software teams. We have 32 member organizations across the industry leading this change. And the efforts of the Green Software Foundation, it must be said, are significantly focused on actually reducing or eliminating carbon emissions as part of the software development process, and not seeking to neutralize them, which is a temporary solution. But we're seeking to reduce or eliminate carbon emissions completely, so that we use less physical resources, we use less energy, and even the energy that is being used is used more intelligently, right? And since you all have registered for the summit, I'm sure you must have more than just a passing interest in the topic. So I will therefore spare you the platitudes about how sustainability is a business imperative and the dangers of climate change. I'm sure we all know that, right? And instead, I'll focus on why we put our hands up to hold this first Green Software Summit, particularly in India, right? So I think what we need now is a movement in the software industry that makes green software principles as core to building software as other concerns like, say, security or functionality or performance or scale, which are what a lot of organizations think about, right? And how can this movement indeed even really take off without finding large-scale adoption here in India? And that's really what we're looking at, right? And India, by all accounts, will be home to the largest population of software engineers, at least in the next couple of years, if we aren't already, by over 5 million software developers by some estimates. And as a problem, we have an imperative to treat this with an urgency that this deserves, right? I made a reference to the Agile software movement. The Agile Manifesto, I think, was signed in 2000 or 2001, so it's about 20 odd years old. And I'd say it probably took about 15 years for the Agile software development methodologies to go mainstream. I don't think we have 15 years for green software movement to go mainstream. I think we need organizations like GSF and events like the Green Software Summit. This is, of course, the first summit, but we hope the first of many. And we hope this is going to be a preamble to an epic rethinking of how software is built with green software principles in mind from the get-go. Right. Again, on behalf of the Green Software Foundation and Thoughtworks, I welcome you once again. We hope to make this event worth your while. The team has worked incredibly hard to assemble a stellar lineup of speakers, talks, panel discussions, and workshops. A special welcome also to our guests from other time zones who graciously agreed to share their expertise and experiences with us, and participants, both physical and virtual. Thank you for sparing us your time today. We hope that you'll be energized with the lineup that we have for you today. And my hope is that each of you in turn will tell 10 more or 100 more people about what they've learned here, so that what we've started today here with the summit can truly become a moment. So with that, I thank you, and Garima, back to you.
So much, Satish, for the important highlights, and also how it's the right time for us to actually, being as a technologist, to focus on the GSF part. And I welcome our next keynote speaker, Andy Nolan, the Director of Emerging Technologies at Thoughtworks in Australia. Andy has over 20 years of experience in emerging technologies, and he likes to put his talent into the real world problems. And also he has a keen interest in the AI and also the computer vision. And he tries to focus these kind of talents into the healthcare, food production, and the climate change. So welcome, Andy, over to you.
Well, thanks so much for having me. I'll just share my screen. Bear with me for a moment. Hopefully you can see that. Let me know if there's an issue. I'll assume that's a yes. So thanks so much for inviting me to participate in the first Green Software Foundation Summit. It's a great privilege, and I've prepared some slides here that I hope you get some value out of. It's an amazing lineup of speakers we have coming after this, so they've set the bar pretty high, but hopefully you find this valuable. So I won't dig too much into why sustainability is a massive issue and why businesses need to react to it, particularly the software industry. I assume your presence here at the conference means you already get all of that sort of stuff. But it's clear to say that sustainability is one of the mega trends that is about to impact or already impacting the world, and particularly businesses. And the ability for us to respond to that is key. Our ability to respond in the next 5 or more years will determine our success in combating climate change. When we think about the impacts it will have on society, but mainly focusing on businesses here, we can start to think about it as there's a need for businesses to undergo a sustainability transformation. And that need is driven by 3 different drivers. One is risk. So climate change in particular poses a substantial risk to organizations. So we can see this in floods and fires that are occurring in Australia, where I'm from. We can see the risk of the supply chain impacts that COVID-19 has had. Businesses can think about climate change as a risk if that suits them. There's also reputational drivers that are enforcing businesses to have to respond to these impacts. So the reputation of being a good corporate citizen and taking action when it's required. There's also reward. So businesses that are seen to be responding to climate change and having more sustainable products or more sustainable business operations will create a competitive advantage that their competition don't have. The key is to start early, because that competitive advantage will be hard to catch up on in the future. So once we have the drivers, we go into this cycle which we're calling the sustainability transformation. And it really starts by measuring. So businesses are either at a stage now where they're measuring their emissions or they're undergoing the process of measuring emissions. Once they measure those emissions, they move into a planning phase. So they move into a phase where they decide on the initiatives that they're going to back to reduce those emissions. They could be things like modifying their supply chain. They could be new products that their customers could purchase that are more sustainable options. There could be a whole raft of different things. Then they move into the optimize phase. So we've finished our planning and now we're starting to optimize our operations. We're reducing our emissions, we're measuring our emissions. We're also taking action, executing on our plan. And then finally, reporting. So we see more frequently now, ESG reporting is one of the key mechanisms that organizations are using to indicate to the market how they're tracking against their goals and what those goals are in particular. At all of these key points in this cycle, we can see that there is a need for technology. So technology will be a key enabler in helping organizations define what good looks like in this space, and will help them measure, plan, optimize, and hopefully report on those. So the role of technology in sustainable transformations really falls into three different categories. We can think about the need for IT itself to do better. So how can we be more sustainable in the way that we develop code, architect systems, run our software in the cloud and things like that? We can also use technology to help businesses be more sustainable. So how can we deploy IoT sensors, data and AI, all of these different techniques to help organizations firstly measure their emissions and then optimize those operations for emissions. And finally, the last one, which is probably the most impactful, how can we create more sustainable products that will help our customers be more sustainable? How can we nudge them towards making more sustainable choices? Now, these three different buckets will all be enabled or driven by technology. And the Green Software Foundation is really about optimizing the actual development of software systems themselves. But once we get over that and we have that under control, we can actually use the technology that we've optimized to help in so many other ways, maybe in more impactful ways. So as a technologist, I'm always looking for ways to use technology to help the world. But I'm a little bit conflicted because, as we know, technology itself has a substantial impact on the environment. So global tech industry emissions are similar to those of the aviation industry. And the tech industry will account for about 8% of total electricity consumption by 2030. So it's pretty substantial when we think about it. One of the ways I like to think about the impact of tech and sort of the scale in which these systems operate is to think about a really simple everyday product or system that we use. So voice assistants. We probably have them on our phones. We might have them in our homes. Things like the Amazon Echo and the Google Home and things like that. Now, these really simple systems are designed to take a voice command, convert it into a command which can then be actioned, like set a timer or play a song or something like that. It seems like a really simple, insignificant little piece of technology. But when you start to drill into it, you sort of uncover that there's this enormous digital supply chain that goes into making sure this thing can operate successfully. Now, an Australian researcher, Kate Crawford, actually went to the effort of dissecting what it takes to make the simple Amazon Echo voice assistant work. She looked at everything from the minerals that go into making the physical device itself. She looked at all of the communication systems that help the device from your home connect into the cloud infrastructure to execute those commands. And she developed this beautiful map, which I'm sure you can't see the detail of because it's so huge in detail, but you can download this and have a look at it when you have some spare time. But I'll just drill into this little bit in the middle here. This is the section where the audio comes in and it's converted into a text command, which is then converted into an intent, and hopefully it does the right thing, like sets the timer or plays a song. We start to understand that this system is operating at a global scale, requiring enormous compute power to train these speech recognition algorithms and to execute them, run inference for many, many users simultaneously. For me, it sort of made me realize that every time we interact with technology, there's a substantial impact on the environment. So as a developer myself, my job is to make sure that when we're developing these systems, we develop them in the most efficient way possible, and make sure that we're not using things when we shouldn't be using them, scaling things down when we should be scaling them down, and using as much renewable energy as possible. So what is green software, and how can practitioners actually make a difference and develop systems that are a little bit more sympathetic to the environment? So this slide here is really taken from the Green Software Foundation's website. And it starts to define what green software is as an application that emits less carbon. That breaks down further into two different buckets. So we can think about carbon efficient code, and we can think about carbon aware code. So if we drill into carbon efficiency, so it's really about doing more with less. So how can we make our software more efficient? So do the same thing, but in a more efficient way, so it uses less energy. And how can we have more efficient hardware so we can do more or the same workload with less hardware? On the other side of the tree here, we have the carbon aware. This is a little bit more exciting and maybe a little bit harder to get your head around, but how can we create software systems that are actually aware of the amount of carbon in the energy grid where they're operating? If they're aware of the spatial and temporal carbon intensity of the grid, we can actually use algorithms and orchestrators to make sure that we're running code at the optimal time of day to reduce the carbon emissions. Now let's dig into the hardware and software efficiency first. So in Australia, when you purchase a new fridge or any white goods, they have what we call an Energy Star rating system on them. So you can have two fridges, one with a low Energy Star rating and one with a high Energy Star rating. Both of those fridges will keep your food cool, hopefully, but one will do it in a more efficient way than the other. So when we think about software systems, how can we design systems that perform the functions that we need to perform, but perform them in a more energy efficient way? So with the advent of cloud compute and the infinite amount of compute that we can use at a global scale, we've been a little bit lazy in the way we optimize software systems. It's easier just to add more resources because it's not a physical machine that we have to purchase anymore. It just becomes a line item on an invoice, really. And there was a famous quote a few years ago, "The free lunch is over," where it was describing the fact that CPU processing speeds weren't continuing to increase exponentially, and that in order to get speed improvements, we were going to need to add more cores, which would create more complexity in the way we write software systems. It's a similar problem here, but now for cloud compute. Instead of continuing to add more and more and more, we need to be a little bit more constrained in the way we develop these systems to make sure that what we are deploying and using, we're using in the most efficient way possible. There's this idea of mechanical sympathy. And the quote around mechanical sympathy is, you don't have to be an engineer to be a racing driver, but you do have to have mechanical sympathy. What that means is that you don't have to understand to the nth degree the CPU architecture or memory architecture of a computer. But you need to be sympathetic of the needs of that computer and the way it has been built in order to develop systems that use that hardware like a racing car driver would in the most efficient and effective way. Now, there's the software carbon intensity specification that there's a talk about later, and they'll dig into that in much more details. But the aim of that project is to provide a scoring system or a mechanism to score the carbon intensity of different software systems. This will give you an indication of where it sits on the spectrum, similar to the energy efficient star rating system. Is this a 1-star software system or is this a 5-star software system? It's a really exciting project and hopefully we can help gain some traction. So the next thing we can talk about here is we need to use energy in a more efficient way to achieve our same goals when developing software systems. And we also know that as we transition away from fossil fuels to more electricity, to more electrical systems and renewable energy, it's estimated that we'll need about 2 to 3 times the amount of electricity we currently use. When we're developing systems, we want them to be as efficient as possible. However, we can't efficiency our way to zero emissions. We have to think about things in different ways and transform the way that we're developing systems. Now, I've been reading this book called Electrify, and it's really about the transition from fossil fuels to electrical systems. And it makes you think a little bit differently about there's different cycles around off-peak and on-peak and the impact that fossil fuels and mixed with renewable energy has on the grid. It's quite challenging, but it actually creates some really exciting possibilities in how we can do things better. And one of those really exciting concepts that the Green Software Foundation talks about is carbon-aware systems. So this is an image or a graph of the energy mix in Australia over the last couple of days. And what you can see here that in Australia, as a nation, we have a variety of different energy sources, but the majority of the energy produced in Australia comes from black coal and brown coal. There's also a substantial amount of wind. If you look at the chart across the bottom, we can see that the base load around, 56% is made up of coal, and it's fairly consistent with little waves. On top of that, we can see the mix of renewables and batteries and hydro and how they're helping with the system. But if we were to deploy a system into Australia that we wanted to have zero emissions, there isn't really a time of day where the carbon intensity of the grid is zero or even close to zero. It's quite high. What if we break it down a little bit further? So in Australia, we have many states. Victoria is the state where I'm from, and South Australia is the state just to the west. If we look at the mix of energy in these two systems, they're actually quite different. So we can see on the left-hand side that for Victoria, there's a really consistent use of brown coal, closely followed by wind and a little bit of hydro there. It varies a little bit, but not too much. Probably not the perfect place to run some compute that you wanted to have minimal emissions. If we look at South Australia though, it's a different mix of energy altogether. We can see different peaks and troughs here. So around 6 or 7 in the morning, there's a peak of energy consumption when people are getting up and putting their toaster on. And around 6 o'clock at night as well, there's another peak when people get home and make their dinner. But in the middle of the day and in the middle of the night, what we can see is that the gas generation actually drops off quite significantly. And most of the load is made up by wind. If we were to deploy a system into South Australia that we wanted to be executed when there was the least carbon intensive time, there's actually some really good spots in there. So if we wanted to reduce the emissions of our software systems, we have most of the day, so that rectangle on the left, and then most of the night where really the emissions coming from the grid in South Australia is quite low. There's a little bit of gas in there, but most of it's renewable. What we can start to see is that the temporal and spatial awareness we may need to have in our software systems is really important here. How can we develop systems that potentially aren't things that need to be on all the time, maybe batch systems or machine learning algorithms that can be executed within a day's time frame, but are fairly flexible in exactly when that happens? We can start to look to the grid, figure out what the carbon intensity is of that grid, and then opportunistically execute these payloads to reduce the emissions as much as possible. If we think about that again at a global scale, we can start to think about how we can use the global temporal and spatial awareness through different APIs and software systems to figure out not only which time of day is the best time to run this piece of compute, but where in the world does it make the most sense to run this piece of compute. We can see here on this chart that Australia is actually quite carbon, or has a high carbon intensity, but there are other regions, maybe in Europe and some in Canada, that have quite a low carbon intensity. If we're thinking about deploying different workloads and we're really conscious of the emissions that are being produced through those workloads, we need to start to consider the intensity of the carbon intensity of the grid where we're deploying those. The next thing we can think about is, how do we incentivize people to care about emissions? And one of the ways we've started to think about it a little bit differently is, instead of saying, here is a chart of the carbon emissions from your cloud compute, and you should reduce those, we've started to say FinOps is basically the optimization of financial concerns related to cloud compute, and GreenOps is the optimization of emissions from cloud compute. If we combine those two together, we can get this thing we're calling sustainable ops. And it's really the optimization of both the financial and the emissions coming from a cloud compute. The reason that's so powerful is because at different levels of the organization, those different metrics will resonate. So for instance, the manager or a CTO of an organization would probably care more about the financial metrics. Whereas we see for developers, they're incentivized by different things. If we can produce a dashboard that has both the financial and the emissions related to a piece of code or a product that they're responsible for, we've seen that developers are much more likely to prioritize optimizing for emissions rather than purely optimizing for financial metrics. And it comes down to that CX, or the customer experience. So how are we presenting the metrics to the right people at the right time so that they can take action? It depends on who you are and what your background is and what you care about. But I think it's really important that the marriage of these two metrics could be quite powerful in organizations and could help to increase the adoption and awareness of how we need to consider emissions and also financial costs when we deploy systems. So we've spoken a little bit about the role of technology and how we can do it a little bit better through the use of carbon efficient systems and carbon aware systems, and even talking about how we can think about metrics around FinOps and GreenOps and sustainable ops, and how we can present them to people at different levels to make sure that they can take action. But what about greening the business itself? When we think about organizations, it starts to get really complicated when you try and dissect where their emissions are coming from. And in an attempt to do this, we've mapped this out on a physical to digital supply chain spectrum. So if we think about on the left-hand side, we have industries that have most of their emissions would probably come from their physical supply chain or manufacturing processes. So we have oil and gas and mining. And as we move more towards the middle, we have manufacturing, utilities. Kind of around the middle, we have retailers, which have a decent physical footprint, but they also have quite a decent digital footprint as well. So their emissions are probably balanced between the two. And then we move all the way across to the extreme right, where we have digital natives. So organizations that are run purely as websites or marketplaces on the internet, don't really have a physical presence. The challenge we have as technologists when we're trying to tackle the emissions coming from the business itself is figuring out where in this spectrum they come from and the industry they reside in. Because the answer to solving them really changes. So for a digital native, looking at things like measuring the emissions coming from their cloud compute, which would probably be their highest source of emissions, is probably the right answer. So how can we help you measure them, optimize them, and hopefully reduce them? But then when we get into the middle with retailers, cloud compute optimization may be helpful, but looking at their physical footprint starts to get a little bit more challenging. So how do we optimize their supply chain? How do we optimize their logistics? How do we optimize their physical footprint in stores and things like that? We need to start bringing in things like IoT, data and AI. Any tech you can think of could be helpful in that domain. And then right across on the left-hand side, oil and gas, where most of their emissions would probably be coming from the manufacturing or production of their products, and probably a very small amount coming from their cloud carbon compute. I'll very quickly tell you this story about how you can think about using technology to help an organization develop a plan to reduce their emissions. So if you remember that sustainable transformation circle we showed at the start, that planning phase is where most organizations are at the moment, trying to figure out what are the best options and how they can reduce their emissions as quickly as possible. Which initiatives should they back? Should they install solar panels on the roof? Should they buy electric vehicles? Should they change their supply chain? Well, Thoughtworks was brought in to help this textiles company, and they were really in that planning phase. They didn't know what to do. They had measured their emissions, but they hadn't decided which initiatives they should invest in and help them reach their net zero target, which I think was 10 years away. We came in and actually helped them build a machine learning model, which was based on conversations with the key stakeholders to help them get that certainty around the roadmap to zero emissions. So they wanted to understand the initiatives that would have the biggest impact, how long it would take, and how much it would cost. So in order to do that, we sat down and asked them to physically draw out their representation of the business and how they think it works. They all had a slightly different understanding of the business and how it works. And we created a shared understanding through conversation of what it took for this supply chain, for the business operations and manufacturing, and also how they interacted with their customers. Once we had that, we converted that into a model, which was a representation of their costs, their revenue, and their emission streams throughout that business. Once we had that model, then we could start to simulate future scenarios. So what if we change this setting over here? How would that impact our future roadmap to zero emissions? What if we change this raw material? What if we put solar panels on? What if we switch to electric vehicles? How would that impact? Using that model, we could start to simulate conversations between the stakeholders and figure out what their intuition was, and we could challenge that intuition and maybe help them find new solutions to that answer. One of the challenges, or one of the stories that came from that engagement was one of the key stakeholders said that we had so many vehicles within our network, switching to electric vehicles would probably be the biggest impact for this organization. So we modeled that out, and he was right. It was going to have about a 14% emissions reduction across the entire business year on year. However, we also modeled out a different scenario, which was switching one of their raw materials to an organic cotton material, and also incentivizing their customers to make more sustainable choices, incentivizing them to purchase the sustainable option. The surprising thing was that they could switch this raw material very quickly, and the impact was going to be much greater than switching their whole fleet to electric vehicles. Now, this is a great example of how our intuition around the things that are going to have an impact is sometimes wrong, and it's often the really boring, simple things that when done at scale will have an outsized impact. This is just an example of how we can use technology, hopefully green technology, to enable businesses to make better choices. There are probably millions of other ways we could do it, but I thought this was a really neat thing that I could discuss with you today, that by using AI, we can simulate new conversations that can help organizations discover better answers to complex problems, maybe even explore new possibilities, and hopefully find that optimal solution for their transition to net zero. One of the other things we often talk to organizations about is making sure that you include sustainability metrics when you're making decisions. So if you have a definition of value, and that will change based on different organizations, make sure that sustainability is included in it. And what do I mean by that? So when you're deciding to fund different initiatives, we need to make sure that we're also looking to the sustainability impact of that initiative. There's no point investing in developing a new blockchain solution that was going to have a really negative impact on our emissions. We need to make sure that sustainability is included at every point throughout the organization in order to ensure that we're going to meet our sustainability goals. Because if we don't include these metrics, there's no way we're going to hit our strategy targets. So the last one here I'll touch on really quickly is the role of customers in helping businesses transform to a more sustainable offering. So when we think about designing systems, we often think about this idea of a human-centered design. And what human-centered design does is it tries to optimize for the individual human's experience. So we can think about that when we purchase things online or interact with different systems. It's trying to give us the best experience that will hopefully get us to come back and buy more and make it a sticky experience as well. But one of the things we can think about is that if we're optimizing for an individual human's experience, maybe that's a suboptimal solution for the collective. A new way of thinking about these things is how can we have more environment-centered design, where instead of optimizing systems for a single user, we allow the user to make more sustainable choices that individually might be suboptimal, but collectively might be better. So what's an example of that? And what am I talking about? Imagine you're buying goods online and you have an option. You can get the goods delivered within the next hour, which would be fantastic for you, a really convenient solution. But it's quite carbon intensive because someone would have to drive to your house and deliver that thing really, really quickly. What if there was another option that said, you can have this goods next Wednesday when the truck is in your area delivering to people around you. And by doing so, you'll have a lower carbon emissions based on this delivery, and therefore you get that feel-good experience and you feel like you're contributing to the collective good. By designing these systems in different ways, we can start to incentivize people and make the impact of our choices more transparent to them. And I think by doing so, we can start to design systems that may be suboptimal individually, but will become part of the brand or part of the service offering that we're giving people. And I think over time, people will become quite comfortable with making those decisions, and it will become very convenient rather than an inconvenience. And I suppose this is the tagline or the message for general sustainability in business conversations, is that sustainability and profitability must coexist. Businesses will resist making change if it's going to impact their bottom line. As technologists, we really need to make sure that we're keeping profitability in mind while also making sustainable choices as much as possible. Establishing a culture of sustainability in your organization is probably a really great way to start. Transforming your digital supply chain is another great use of technology. There's so many different ways, as we briefly touched on, that you could implement that. And last but not least, enabling your customers to make more sustainable choices. Out of all of these things, maybe the customer one would have the largest impact, who knows? Thanks again for inviting me to present. Hopefully you learned something and got something out of that. But yeah, I don't think we have time for questions, but I'll hand it back. Thank you.
Thank you so much, Ali. Though we have 2 questions, I hope we can manage to answer them. And there's 2 questions. One is from Rohit Mehra, and Shriram has also mentioned that he will be talking about it, but we would like to have your thoughts on this. So the question is, why sustainability is usually not specified as a core non-functional requirement by most of the clients, and is the landscape evolving? Your views on that?
I think it's evolving. So we're seeing, Thoughtworks is a software consultancy. We're seeing more and more RFPs that we respond to where sustainability is a key criteria. So how is the system going to be developed in the most sustainable way? And also, how is the organization, Thoughtworks, what are their credentials around sustainability? I think we need to consider emissions when we're developing systems, and I would encourage people to try and push for them as requirements when they are developing these systems. One of the most common things we hear from sustainable professionals is that they can't get their hands on this data. They can't get the data that they need. As software engineers, we can make that a little bit easier by making sure that the solutions that we develop actually produce this information alongside financial metrics. I'd like to see that happen, and we've seen glimpses of that happening here in Australia. So fingers crossed it's a more common thing.
All right. Thank you so much. And the next question is from Sushmita. Is the onus not on us as a product developer or business who creates products that are addictive? Infinite scroll autoplay videos, we measure success by the time spent on the platform. So how can we achieve our sustainable goals if we hook users and be a victim of the digital addiction ourselves?
Sorry, I'm just plugging my computer in before it goes flat. I think that comes down to the environment-centered design approach. So we've been obsessed about human-centered design for the last 10 years, and maybe that's suboptimal for environmental causes. Perhaps making, I saw a video recently of an OS that's actually carbon aware, and it degrades the performance based on the carbon intensity. Maybe that's a little bit extreme, but using elements of that into the designing systems could be a really advantageous thing, because I think we're so comfortable with infinite compute and always on compute, providing these services whenever we want. Maybe we need to make people a little bit more aware of the impacts that those are having, and maybe by exposing the carbon that's produced by these interactions could be a positive thing in helping people get that awareness.
Thank you so much for this informative session. And to summarize the session, so in the session, right, Andy pointed out many important points on how technology can be actually the key for organizations to understand the risk and measure the omission, and how they can optimize the report, right? And how tech can help business in sustainability. How simple tech devices like Alexa can also contribute to the emission, and the anatomy of AI systems, enormous speed powers that it requires. And yes, not to forget what is actually a green software and what is being carbon efficient and what carbon awareness systems are. Understand the software carbon intensity so that we can actually understand what is the scale that we are emitting the carbons and how we can actually optimize it. We also had a very large talk about the fine ops and the green ops, so that the combination can actually lead to the sustainable systems. And actually, it's the steps that we can follow to attain the sustainable transformations. So thank you really so much for this informative session. And the next talk that we have is, just a minute. So yes, the next talk is actually on the architecting and the developing for the lower resource utilization by Mr. Shriram Narayanan. And Shriram Narayanan is actually Yes, he's the principal consultant infrastructure at Thoughtworks in Singapore. And Shriram is having 27 years of experience. He has been an entrepreneur, a consultant, and security expert and whatnot. He presently is advising customers on the continuous delivery and is a regular speaker. Over to you, Shriram.
Thank you very much. Thank you for that very good talk, Andy. And you brought some very good perspectives that I had myself missed out on, and I'll try to weave those in from my side. So folks, just checking, can you see my screen? I'm making a mistake over here with sharing the screen, I think. Unable to see the screen, all right. So let me stop and share again. Share the Right, can you see it now? Just confirm, please.
Yeah, it's visible.
Thank you. Yeah, thank you for that introduction. Hi, folks. I'm Shriram Narayanan. I'm known as Ram. I've worked at Thoughtworks for quite a number of years. But prior to this, I have worked in certain very other interesting industries. I've done a bit of industrial automation. That means I've used PLCs and automated factory shop floors, and got to work with real electrical technicians and do a lot of such interesting stuff. I've done CT streetlight automation, and also interestingly, the power energy and the utilization measurement for all of those things. So I've had my good fortune of working different things. When I was requested to present on this topic, I decided to have a very interesting and different take. Like Andy, I too will not dwell too much on why was BB sustainable. There's enough data and resources outside for that. I decided to take the view of what is in it for us as the individual and us as teams when we get out to designing software and when we play a role as IT professionals, right? This is not about, please keep only so much light switched on at home or whatever. This is about what is it that you as an individual can do? What is it that you as a team can do? The reason I decided to take this focus is I'm part of a lot of sustainability events, and I follow a lot of such things. And one common message by every individual over there is, my God, there's a huge impact on the planet, but whatever can I do other than use less plastic bags, right? People are stuck in this. And then you also have the message of, oh, don't worry, every drop counts. So I decided I'll take a spin on that and present to us all about what is it that we can do from as IT professionals, and can we indeed make an impact, right? So that's what this talk is about, yeah? So these are the things we will cover. We'll cover what is this low resource utilization mean, and Andy's covered some of those. I'll give a different point of view perhaps. And we will cover a lot of these things. These are all topics that are going to come to us on projects, yeah? Okay, the scope of this talk is just general architectural advice. I'll not talk about, things like high performance programming or how you optimize your code. I'll not really talk about that. There are many books out there. There's a lot of good stuff out there. Yeah, I'll also not talk about specific optimization techniques like use this flag and do that particular setting. Yeah, I'll also not talk about what calculation formulae are the best or most suited or whatnot. I'll not get to all that. I'll talk about what can you do as an individual and as a team, and what some general architectural advice. Yeah, just to get a few things out of the way, lower resource utilization, just so that we're on the same page. Yeah, the general understanding, as I have seen it in various talks and talking to people, is using lesser compute, using lesser IT resources, and actually eventually using lesser energy. Yes. Then the question comes up of why, right? Why should we try to, is it really worth trying to reduce this kind of an IT spend when, developer salaries are expensive? We'll cover things like that, right? Why? The whys are these: reduce energy consumption, reduce architectural complexity, reduce costs, right? That there are very legitimate reasons for these. And how do you go about it? You go about it by, these sorts of approaches: more efficient code, better architecture. We'll just see a little bit of it. Yes. Yeah, making the case for this, correct? Okay, the top thing that I have heard, when talking to many folks, especially those in startups or clients that we work with, is developer salary expense is high. Yeah, they would rather throw a lot of compute at the developers and tell them, just get this done. I want to go live, and you all pack up and leave. All right, I understand that the upfront immediate term operational spend, and the fact that you want to use the most expensive piece of all of it, the developer time, more efficiently. We understand it, right? But what happens is, just as work expands to fill time, right? If you have a larger budget, people learn to use that budget. So if you will have, then you get into the real complexity of, is that solution actually going to be financially viable once your development team is off? Correct? Is that going to be financially viable in terms of the cash flow and the fund flow of the organization? Cash flow is the cash that comes in and out. Funds is all the investments that come in, right? Not necessarily as a part of a customer purchase of your products, right? So these things are very important. The other thing that comes up is convenience. Yeah, we are often told about, hey, don't worry, it's the cloud. I'll give you an account, just go spin up what environments you need, use them and walk away. Correct? We have often seen, it's a matter of discipline, that developers, client-side people, many others, that people spin up infrastructure trying to make a point, sometimes trying to deliver also. But often this results in infrastructure sprawl. That means VMs that are spun up and are just left lying around over there. Everything costs, things cost, and it's not just financial costs, just a waste, right? You get into the mindset of consumption and wasting. And then there is, of course, the point number one here, which is the case of too many microservices. And I'll cover this kind of a topic it just coming up also. We do see that there is a lot of feel about, hey, the new cool way to do stuff is not to be monolithic, but to use microservices. Yes, sure. But one has to understand what is a microservice, why would you use it, how do you necessarily need to architect it? And then, avoiding mixing various concerns. There's a dedicated slide on this topic. Okay. Oops, I did not complete the slide. But the bigger point over here that we see often is when architectural complexity comes up because you mix a lot of concerns get conflated together. Product design, team composition to align with the product, then there's Conway's law. When a lot of these kinds of phenomena start to surface, and you start to see the impact on teams, you will start to see Conway's law coming up. You'll start to see the way people approach a solution is often influenced by the budget, by the way the team is composed, by the deployment tooling, and by whatever cool tech that the team wants to do at that time, right? These often have a huge impact, correct? And a lot of that is often done in the name of convenience. That's not necessarily the right way to go about it. Yeah. Yeah. So one thing that we have seen often is there are people who do not really understand the tech stack. Yeah. And the more tech stacks become easier to use, the more things they abstract away, and the more people work only at those higher layers of abstraction. For example, it is very cool and common now to just go microservice first, without people really understanding that if you want to follow, let's say, something like domain-driven design, and you arrive at domain entities and components, they do not necessarily have to also run as individual separate processes. This sometimes comes as a shock to people that, there is something called object-oriented programming where components can be auto-wired together, and you can just have your business outcome given out to you, right? There are many dev movements that we see nowadays, or even, company client trends, where we are seeing a microservices first mindset, where they do not understand why are they opting for microservices. To give you a very small example, there's a friend of mine, they're running their company and they're creating their product. It's actually just a very nice, interesting business reporting dashboard system. Yeah, that's what it is. They've gone and pumped in around 15 microservices over there with a 5-member team. That's it. It's a 5-member team. They've gone and created microservices, which nobody asked them for. But that's what they did. Why? Because someone at the start thought that's a cool, correct way. And only that way can you convince the boss and the customers that you're doing the right thing. So no, one must not mix up a lot of these sorts of things. It is wise instead to start monolith first. And there is a growing realization about this for the past few years. And if you visit martinfowler.com, he has got 2 different articles, one which argues for microservices or makes the case for it, let's say, and the other which says that why must you start monolith first? You might think that both are contradicting each other. No, both are just telling you what are the points of view that you must have. Yeah. And this other point, right, is very interesting. Are you just pulling functions apart and calling them microservices? Many people, that's what they actually do. So just having, just like there's a fairly, generally well-regarded person I've attended a talk where he actually said, oh, you know what, just pull every function out into a microservice. If you don't like it, just discard it. Don't even bother writing tests. There's a lot of such kind of, advice given rather loosely, but it causes a lot of these kinds of baggage and luggage that, people have to cart and take care of over the long time. And these lead to inefficient architectures. These lead to, higher expensive compute that you have to throw at the problem. And it's all not really required. And then these things also become very operationally difficult to run and maintain. So what has all this got to do, with green software and climate change and all of it? It's just that once you get into a waste mindset, you often are not able to condition yourself to go back. And how do I say this? I say this because I used to be a regular software developer. And I then went into industrial automation, where it was a very safety first, high speed processing kind of a world. And it took me many months to let go of my general mindset and to get into that. Yeah. So this is important, that if you condition yourself to waste, you will waste. Yeah. And it will spread in many ways. Then there is this other thing that I put over here, it's also about making the case to business people. This is a problem for a lot of us in a typical software lifecycle, where you develop some software, then you show it to an internal team, where the users come and they give you an acceptance. There are clients where we work with, and to tell you the truth, we are still struggling with trying to educate and make this case. There are client situations where they say, look, I know whatever you did may be good, but why don't you make it work in my environment, which has to be full blown and full fledged and all of it. With often them not understanding that there are license, operational, and maintenance costs of all of this in the long term. Some of it is not really needed, and there is a lot of overhead. Yeah, so there are costs in all sorts of ways over there, and that's yet another huge waste. So this often is a journey. It's one of the things we have to learn as consultants also, that how do you explain to someone that there is a better way and a less expensive way, in all sorts of meaning of the term. A less expensive way to go about doing something. Yeah. So this is a problem. It's not always easy to solve. And I think it's only with wider realization that it can happen. That's where we have a role to play. Okay. I'll suddenly shift focus to what is it that we do as a delivery team, of what we could do as a programmer. Yeah. One of the things that one could consider is your code efficient? Right? Is a code that you're creating, is that efficient? Are you doing the right stuff? We all know about things like app dynamics, and there are various such online tools which will profile your code and give you answers. Do you actually use those? Correct. There is in the getting started section at the end, which is also like the resources, I've mentioned a website of this very nice performance engineer called Brendan Gregg. Yeah, he's written a book called Systems Performance. The second edition is really good. He is an engineer who's worked at places like Netflix, Sun Microsystems, Joyent, and now he's at Intel. So people like these, they've written all very good kind of blogs. They've written the right kind of articles, which I would urge that you go and have a look at those. There's a concept called flame graphs, right? These are all very well documented. Please do have a look at it. This is where you understand that when you use a profiling or tracing tool, there are two very interesting aspects to look at. Which actions take time and which actions are wastefully repeated. These are two different kinds of wastes. One is of that function call where everything happens within milliseconds, but this one thing takes 2 seconds. Okay, that's a hotspot. You want to pay attention there. But you may also have functions that get over in milliseconds, but which are called like 500,000 times. That's another area to look at as well. Yeah, because there are two different kinds of inefficiencies over there. The other is it's one of my happy favorite examples. There was this team that I was walking past and I overheard them discuss something, because I kind of like operating systems. I overheard them and it occurred to me, they were using some native Ruby parser to parse XML. And that's when I suggested, hey guys, why don't we just look for some other parsers which might be using native C-based libraries to parse XML for you. Yeah, they had a look at it and they just, something that would have taken around 15-20 seconds, they cut it down to a few milliseconds. So sometimes we have to make a trade-off between a language of convenience, like a very high quality interpreted language, versus certain functionality that you can push lower down the stack in terms of, using more native code. So these things are done. So that's how a lot of stuff happens with NumPy, SciPy, and all of these things, right? There's only so much that they do in Python and then they fall below, right? They fall to native code. Yeah. So are there languages or libraries that can replace inefficient code? It is worthwhile exploring, all right? Because, when you come up with all these efficiency reporting and all of it, performance reporting is not going to be the only thing. People are going to start reporting how energy efficient is your code. And then when someone produces that report and say, oh, I'm going to add this as part of a formal contract, what are you going to do? You're going to start using approaches like these, right? Then this other thing might seem common sense, but sometimes we forget it. And I have made this mistake in my life. Is there a different way to perform that action? I have made this mistake in my life. There was this time when I was all object oriented and whatnot. And when I had to load data from a flat file into a database, I made the mistake of first reading, line by line, materializing a whole object graph. And it was an object graph, right? Materializing a whole object graph and then traversing it and, firing the right database calls and loading it in. So this was some bank record system that we were developing in an earlier job. And my God, that thing took time, man, right? That thing took time. And that's when I called another colleague. I said, look, I've done this for 3 days. I think there's something wrong I'm doing here. Why is this taking so much of time? He had a look and said, why are you doing all this? Why don't you just, load it by the database native tools? My God, you see, I had a bias at that time. I was so thrilled with all my programming. I took a programming first approach. Yeah. So I think this is very important. For the desired outcome, what might be the best way to achieve the desired outcome? We as techies are going to have to start to think about all this even more, instead of just saying, oh, cloud compute is cheap, just throw some more cloud at the problem. Not necessarily the right answer in just about every case, correct? Another thing that I'm seeing with, and I don't have any things to, any project names to rattle off right now. There was something on Hacker News a few days ago when GitHub said that they were retiring Atom and someone else said, oh, we are going to come up with something to replace it. They're going to go as native as they can. I have been seeing a number of projects which are trying to go as native as they can or as low level or systemic as they can. I don't know how prevalent this is, but at least here in Singapore, in a lot of places that we work with, there are clients who say they no longer want to use a lot of these cross-platform approaches. They understand that the cross-platform approach will save time, but they've also been a bit bad and they would rather have two parallel teams working on, the respective mobile native approaches to solve the problem. Is what's happening in the project I'm with. It's happening in a bunch of projects, that I see around me. So I'm seeing this sort of a move, and I don't have any, pro or against point of view, but I'm seeing this, that the code that the teams end up with turns out to be very system efficient. And that is a huge ask that's going to come up in this future. It's already happening, right? Okay, I will now shift track again, the topic of continuous integration. This is a topic that has been, this has been discussed a little bit recently within Thoughtworks. I've not been privy to it, but I'm a huge continuous integration fan for quite many years. So continuous integration is where, the code between all the people is continuously integrated, right? There's an unfortunate, phrase called CI/CD. Actually, continuous delivery includes continuous integration. There are a lot of things that lead to continuous delivery. So I abstain from saying continuous delivery. It causes a lot of ground level problems. So continuous integration is when the various members of a team, their code is continuously integrating with each other. This could be on the main branch, and usually it is the main branch. If you're integrating, just at your feature level, great. That means you're continually integrating within your feature. When you have to integrate back with each other, what happens then? Yeah, so continuous integration. Now, with that out of the way, in continuous integration, what happens is, rather than, the traditional approach was for a team tech lead or whoever to take all the code, compile it, create a package and give it out. But with continuous integration, what you end up doing is you end up having a software agent that performs all this computation for you. Now that can get expensive depending upon what approach you take, right? There are situations where people, they just push all the code out into the CI system, then it bombs out, and then they're all, then you have to fix it again and try it again. That's a waste of time. So one thing that you can generally do is just run the test locally first. So that way you keep the continuous integration system as green as possible in terms of green being tests are passing. Yeah. So the other thing is also to see what can you do with running tests in parallel. This is something that's not thought about very much, but it's actually a very quick time and compute and many other such kind of a save. Correct. Then there are also places where people set up their CI to work on a per commit basis. Sure, but what really are you trying to achieve per commit? Is it okay to bunch a few commits together, and given the right test suite, you can find out which commit was bad, revert it or fix it and send it next, right? That is where you can have a per commit based trigger or a reasonable polling interval trigger of say 5 minutes or 10 minutes, right? It does require good test discipline, correct? And well, the case of composing your CI process, well, I'll just show you this next slide. Yeah, this is happening, at a client that we are consulting to. So they've got a very well organized mono repo with sub projects for 29 services and 30 shared libraries. It's actually very, very nicely done. I enjoyed having a look at it. For reporting reasons, for every service, they've set up a Jenkins job. And in each Jenkins job, there is a standard code compile packaging and all of it, plus a lot of the security scannings per service. Yeah. So the people who read the reports and everything, that is how they thought they should do it. So they prescribed something like this, and the DevOps team, they haplessly went about and created something this way. So today everyone's wasting time with all this nonsense, and they try to reduce their costs and all. They came up with some 10 low CPU agents, and now each of these jobs, they take around 30 minutes per fresh job, correct? Whereas we've stepped in and we've shown them, hey folks, it's just one higher CPU agent, right? Yes, it's going to cost you slightly higher per agent, but with just one higher agent where you use caches, right? A full run just gets done in 5 minutes because we run a top level build. This is a bit technical, folks. This is how builds are composed, but with just the right kind of thinking and all, which they had already paid for and they have in place, we just used it. Saw that that's in place. And instead of all this nonsense and time waste that's happening, we are walking them through, letting go of what they thought was convenient to come to something better. So what I wanted to say over here is, sometimes just because things are in place and they work, like that saying, if it ain't broke, don't fix it. That's not necessarily, it doesn't necessarily have to apply. You can see what improvements can you bring about. Correct? Oh, just a moment. Okay, is there any example where the code is more efficient in terms of performance or time, but not from an energy perspective? I would say, see, there is a recent discussion within Thoughtworks about the costs of machine learning. So there was one colleague who gave the point of view that processing that massive data set takes just a lot of power, but once processed, you can reuse it a whole lot of times. So there is that sort of, I think this is not very well understood and realized yet, but you could take that as one example, right? It's also possible that just because something is cool and it is efficient and it uses less developer time, short-term thinking, you might throw a lot of compute at a problem and try to solve it. Whereas if you could have just run it as a slow running bad job through the night, maybe that would have met the needs. Right. I think my apologies. I don't have any other examples other than this and the CI offhand. Yeah. All right. Okay. Now, can we really make a difference? Excuse me. I need to move some windows around. Can we really make a difference? Okay. This is an interesting question. Can we bring about change? This is where, what can I do? I'm just an individual. Yeah. What I have seen, and I've been fortunate to work at Thoughtworks for quite some years, and I've seen a lot of interesting transitions, correct? I will tell you that, yes, it is possible to bring about change, right? It is possible because we in the IT industry have done it. And in fact, the way we deliver software to customers, the way people respond, the way contracts are written, the way you can, pivot in terms of business direction, the way finance is deployed, a lot of these things have changed. Because now people say, just as we can say confidently, there's a cloud, we'll just use it, right? I need more VMs, I'll just spin it up there, I'll give you an answer in half a day. The way the way mindsets have shifted, right? With technology innovation and new approaches, this too happens now, right? So I have seen, people move to a version control system. This has happened, right? We now do have systems, and when we walk into client places and we bring about continuous delivery for them, we have to bring these things about, right? These are people who share files. These are people where, the tech lead or some code build-up guy runs the whole build, on a Friday night, right? We have brought about a lot of changes in such situations. So I can tell you change is possible. So one of the things that came up was FinOps, yeah? So think about this. I mean, FinOps is something that we are trying to follow. Our clients are not thinking about it yet, but once you understand how reporting works and how regulated reporting is going to come up, you will have to, learn to do your bit for that. To give you a very concrete example, there is in Singapore, the Monetary Authority of Singapore, which is equivalent to the equivalent to the RBI in India. They are different in nature. The Monetary Authority had a 2-hour-long presentation last year, where the Monetary Authority, the General Investment Corporation, JP Morgan, and one other company, they all got together. They gave a very interesting talk. The Monetary Authority of Singapore has published its green computing paper. They have said that going forward, they're going to, over a period of time, start requiring people to start reporting the carbon footprint of what their software does and what their business does. GIC made an announcement. The video is there, so I'm just kind of paraphrasing. GIC made an announcement saying they have pulled their funds out of, a lot of the higher carbon industries and investments into lower carbon footprint investments. They've done that. These are people who work with like a few $100 billion, right? They've done it. JP Morgan made a case there saying they are going to fund much more green work, but civilization still needs oil, but they're going to continue to be in the oil sector while nudging them to improve their efficiencies and reducing, the environmental pollution and other such unfortunate things. So these regulations are coming up. These kind of workflows are coming up. That fourth company, I forgot their name, they had a very interesting point where they are using not a blockchain, but a distributed ledger, where they're going to do an entire supply chain tracking. A supply chain tracking where, for example, let's say there's a product that you have. I presume that in the future, you should be able to take a QR code scan and get a full listing of what was the carbon cost of this product that you purchased, which is right from the fields to the vehicles that transported and all of it, right? Very interesting. So these things are coming up, yeah? So what's in it for you as an individual? What's in it for you as a team member, correct? So the thing is, for you, the more you as an individual learn about a lot of these things, learn about the reporting, learn about how to, coming up with more energy efficient and compute efficient code, your demand is going to increase. The demand for you is going to increase because you know what mindset to have in order to, what mindset to have in order to make that happen, right? That's a value add to you and a value you bring to the table. it's also interesting and important for you because you're now going to diversify, right? You're going to diversify from just being a programmer to understanding a wider set of demands that are coming in, including things like energy efficiency, which reports are going to come in just a month later. Yeah. So how do you write code now for something that where the outcome you're going to see just a month later at the minimum, right? That's going to start coming up, correct? But it is still worthwhile for you as an individual because you will start to see the outcomes in terms of what's happening by the day, right? You will start to see outcomes in terms of the civilization is changing, reporting is changing, governance is changing. Are you going to start being aligned and are you in with the program, right? That's great for you. In terms of the team, right? Some of this is a little bit tenuous, right? It's a little bit weak of an argument that I'm giving you from a green software point of view, because many of these things, you can have general team efficiencies, right? But what happens is some of these things are a little bit cross-translating. For example, better architecture, better packaging and deployment mindset and all of it can lead to lesser complexity. I'm making a slightly tenuous argument, but not so much from a power efficiency, but from a team efficiency point of view. I would argue that some better architecture can have this sort of a side benefit for you, right? Your team can focus on starting to provide value. This third point is very interesting. Avoiding becoming an expensive team that is culled. Those of us in software, and we know a lot of our friends in many startups and other such, highly pumped funds places. We know that once their delivery is done, they are sent out. We are also brought into situations where, someone would have created something they've done for 2.5 years. The product is out there, but the client turns to us and says, God, this is expensive to run and maintain. Can you give us a better approach? And then we have to apply our brains over there. We are not any less expensive, but the thing is, we are asked to now come up with solutions that are financially viable for the client to run. Correct? So you as a team, if you also understand all of this, right, you also stay away from a lot of lavish spending and you make sure that you make the client's money last. The more it lasts, the more they see that you're giving value. You are part of the revenue stream in a way. So there is a bit of advantage there too. Yeah, money and funding are expensive.
Sorry to interrupt, just time check.
Time check. Yeah, this is my last slide. I guess I just wanted to say that, you will not be risking your career and growth. You will be adding value to yourself. Correct? This is important. This, I think, is a very interesting thing. As part of my own green initiative things that I've been looking at, direct air capture is one of them, nuclear fusion is another. What I have seen is a lot of these kinds of domains and companies and organizations, they are going to have a lot of IoT out there. Yeah. And as part of having a lot of their IoT stuff, there's a lot of data processing. They need to know efficiencies, viability, because the pressure on them to prove themselves is much more, unfortunately, it's much more than your traditional oil and coal companies. So they have a lot of these kind of reporting requirements from not just government reporting, but also literal financial viability point of view. So there's a lot of reporting requirements coming up out there. There's a lot of security aspects that they have to take care of. It's very unfortunate. I'll not get into politics of it. Then they are also open to a lot of interesting new architectures. Imagine a huge fleet of windmills over there, right? You're going to have edge devices planted into each of it with reporting coming in all the time, and you may have to preemptively, proactively go and fix things that could become faults. A lot of fast Fourier transform opportunities, right, to predict for fault prediction. And then I guess this is what is very interesting and exciting. It is not that, oh my God, all our typical programming has gone down the drain. We have to become C programmers or assembly programmers again. That's not what I'm trying to say. What I'm saying is there are totally interesting businesses, business directions, and career opportunities that are going to come up. And if you can be part of it, you have many more years of, leading a productive and rewarding career in life. Yeah, folks. So just some links, if you can just go ahead and take a screenshot then. So this is a very good website. Brendan Gregg, I'd mentioned about him. FinOps, here's a link about it. A lot of good governance and reporting that's there. I would say understand governance reporting in your company and your client scenarios. And I'm sure there'll be a growing number of discussions on efficient architecture. There already is. I think there'll be more. That's it, folks. Thank you very much.
Thank you so much, Shriram, for this inspiring session. And to
Thank you.
summarize, thank you. And to actually summarize, there are very little and small steps that we actually can follow to, reduce the resource utilizations, like actually understanding where to use the microservices, just not to use them because they are in trend. And use the containers or maybe test containers or maybe the mock environments instead of the real ones. And have a safe mindset, not like a waste mindset, I would say. Considering simple steps like is your code efficient and in terms of the resource consumptions, and yes, also the continuous integration part, how you can actually make it cost effective by simple step, that is, just run your test locally instead of going for the resources in the very first place. Thank you so much. So the next talk will be presented by Kunal Malik. He's a lead consultant Thoughtworks India. Kunal also leads the GSF sustainability initiatives for Thoughtworks. Kunal has been also working along with different sustainability initiatives since 2008, and he has led the sustainability initiatives at Virgin Atlantic Data Center and SAP Labs. And he will give you a quick peek on the server optimizations. Kunal, over to you.
Thanks, Karima. And hi, everyone. So basically, I'll just go ahead with the lightning talk. It's just a quick, short peek. What is server optimization and what's the biggest conundrum? Before we go ahead with understanding this, let's understand what are these terms. So we have three terms here: a server optimization, conundrum, and a sustainable solution. So let's see what are they. Server optimization refers to around three different areas: data processing, application configuration, and overall performance of the servers. So data processing refers to the ease of use of processing of data, which everyone wants. Everyone wants it to be processed quickly and instantly. In terms of conundrum, it's just what is the confusion around it. So we need to understand that. And at last, I'll be talking about the sustainable solution. So let's first go and understand what is this confusion all around and why is it affecting everyone? What can be done? Let's take a quick peek there. So first thing is, let's understand the what and the why. So when we talk about servers, we have two different varieties of servers. One is the on-premises servers, which have been since ages, in the last 2-3 decades. And the recent ones are the cloud-based systems, which people are shifting to. So let's see both those aspects. So when we talk about on-premise servers, since the last 2-3 decades, if we see, the cost of procuring a server has gone down very significantly. Nowadays, it's whenever a project gets approved in any company, whether it be an IT or a non-IT, it's very easy to procure a server in the project cost, which was not the case earlier. And the reason each project procures a server or a machine is why? They do not want the performance of the application to be degraded when they go live. They also want to test it in a, you could say, a streamlined environment, no disruptions, nothing else. But is that the ideal case after they go live? Yes, they monitor it for a certain period of time, but not after and after multiple releases which happen just to test out the sanity. But once it is stabilized, they forget about it. So those are the active monitoring, active server capacity utilization. Those things, they take a backseat unless and until some kind of a problem arises. The problem could be the server is overloaded, the application goes down or something, then they check it. In terms of cloud, what's happening in terms of cloud? The server space that is being estimated, because of this fear, it has also latched onto the cloud thing, and resulting in people going and the managers or who were the ones are responsible for procuring the space for cloud, they tend to procure around 3 to 4 times the space necessarily required. Despite the fact that it is very easy to increase the space required on a server or the capacity required, but there is an inherent fear which they have faced in terms of on-prem that has latched on, that we might have an application performance degrade and stuff. So we need to come out of that fear if you're on the cloud-based. And on on-prem, definitely we need to do this. But what? So this was the basic understanding of what is the confusion all around. Now let's go to the next step. Who faces it? It's not only faced by the IT companies all across the globe, but since they are into IT, they know the solutions. They're trying to optimize it one way or the other. But who are the primary businesses? They're the non-IT companies, whether it be in any sector, banking, airlines, manufacturing, you name it. For them, IT is just an enabler. It takes a backseat always. Their budgets or their main focus is on their core business, not on IT. That's the reason they do not know how to fix it. But they have their own IT staff, which acts into play when these problems arise. So what can be done exactly? Let's have a quick session, a quick slide to see what exactly we can do. What are some small techniques? So basically, if you see, normally when we analyze a lot of servers across various industries and the data centers and stuff, we found that when those applications went into production and they were stabilized, most of the servers were utilized like 10 to 15% only. They were not utilizing more than their capacity. Obviously, the kind of energy being consumed by a server is huge. But even if you run it on an 80% capacity or a 15%, doesn't make a difference. It consumes the same amount of energy. So the ideal situation should be that you should be analyzing the hardware constantly. How much is free, how much is being utilized, so that you load the server up to 80% of its capacity. But why 80? Why not 100? Because if you have concurrent users logging onto the system who can latch on, automatically the server utilization goes up and it will reach 100%. We do not want any applications to go down. Definitely other factors like upstream and downstream dependencies and those factors need to be taken into account. But all of that needs to be considered, and the optimal should be in the range of 75 to 80%. That's the whole idea. Then in terms of a cloud-based, when we estimate the space required, we should actually latch away from the on-prem solutions which we had earlier. That is, we should not have the fear of getting a space increase later on. So we should estimate whatever space is required, keep a low buffer there, because we can very easily increase the space. That's always there in any of the contracts signed with any of the cloud-based providers. So that's, and in case over a long period of time, we monitor and we see that we have a lot of space vacant, we should actually free up that space. Freeing up that kind of space on cloud saves money at least. And if you're not using it, you can use it for any other applications which your firm is deploying. Now, but what's the final outcome of this? So when we talk about outcome, when we consolidate these resources, ultimately, if it's an on-prem solution, you save a lot of server ports, you optimize the server usage, hardware and software wise, and in terms of expenditure, whether it be cloud-based or on-prem, both get saved. Now, there was one point which I mentioned at the start, sustainable solution. Coming to that part. So how does it help in sustaining the environment, helping in the climate change, and that kind of stuff? A server takes a certain amount of energy to run. Whether you use it 15% or you use it 80% or 100%, that energy consumption never changes unless you're increasing the hardware. Let's say the hardware remains constant and you just run it at 15%, nothing happens. So why not club those softwares or independent applications or applications which can be clubbed post-analyzing together, run it at 75 to 80%, increase the energy efficiency. Not only energy, it also leads to increasing your hardware efficiency there, thereby contributing to an indirect cost and saving and contributing to the helping the sustain the climate change. Also, let's say if you have an on-prem servers, in that case, the shipping carbon emissions here because of shipping costs. Not only shipping costs, but the transportation mechanisms, maybe trucks, maybe ships, or whatever it be. For installation, folks come around to the premises to do it. Saving carbon emissions there. So all of that gets saved. That's just a small amount. And if we start seeing whatever is the cable cost and everything, or the cable when we fix those cables for servers and everything, the amount of emissions saved is huge, literally huge. So that was an outcome there. Any questions?
We have one in Q&A.
Just have a look at the question. No. The server utilization would not vary because unless and until you increase the hardware. I hope I was able to answer that question. Thanks, everyone.
So much, Kunal. So that was really great to know about very small twitches that we can do for the server optimizations. Considering the software, the hardware, and the cloud. So we'll have a 10 minutes break. So people can have and go grab something to eat and drink, and be free to get out of the session and yeah, the next session will be in 10 minutes. So it's like the most awaited session. It will be a panel discussion. So waiting for you guys.
ये तो आप कह रहे हो लेकिन Amazon के जो जेफ बेजोस है और
Everyone,
मैकेंजी बेजोस
welcome
उसकी वाइफ हेलो रिकॉर्ड
Welcome back. So, this session is about to have a panel discussion now, and the panelists we have. So, first of all, this panel discussion is about the sustainability engineering in modern tech business, and the focus will be what are the actual challenges that we face in technology and in business regarding the sustainability. And let's hear from the leaders themselves. So as panelists, we have N, we have Daniel, we have Elizabeth, and we have Nagarjun as the moderator for the session. So a few lines about them, just to you know them more familiar. You get more familiar with them. So basically, N is the director of Xero, director of sustainability at Xero, Australia, and N's mission is actually to help as many people as she can, so that on the planet itself. And her career has been dedicated to understand how to solve these social complex problems with the help of the technology. And Daniel, he's the lead engineer and also a green tech advocate at Thoughtworks in Europe. Daniel has over 10 plus experience, and he thinks that technology should be a solution to the environmental problems, not to be one of them. Elizabeth, she's the executive director of environmental stewardship at Providence, USA. And on Earth Day by 2020, right, Providence announced its goal to be carbon negative by 2030. And Elizabeth is putting her entire efforts in achieving the goal. Nag is the global leader for emerging services in Thoughtworks India. And Nag team works with clients to invent the future using the autonomous vehicles tech, XR, clean tech, etc. So that's all about them. And over to you people.
Thank you. I hope you can hear me okay. All right.
Loud and clear, Nag. Thank
Very
you.
good. How much time have we got?
45 to 50 minutes for the entire discussion and 10 minutes for Q&A.
Cool. And well done on starting on time, because these sorts of things are difficult to manage, especially for a large complex event like this. So well done. So we'll try and keep this to about 45 minutes, as we said. Try and keep this as informal and as free-flowing as we can. But perhaps we'll first start with Anne. And Xero is an accounting software company. So why have you brought sustainability into your corporate agenda? Do you want to talk about that for a few minutes?
Sure, it's a great question. For those that aren't familiar with Xero, we currently support 3.3 million small businesses around the world to primarily manage their accounting, but with our ecosystem or app marketplace globally, we have 1,000 plus apps that plug into their Xero experience and help them with a bunch of other stuff that a small business owner would need to do. So I was brought into the business just as we were piercing the top 200 companies list on the Australian Stock Exchange back in 2019. And the company said we wanted to continue to be a responsible, dynamic, and engaging brand. It matters in terms of how we get access to capital from investors who want to see us as a company that's really doing the things now that set us up for success as a company in the future. but then also things like getting access to the best talent. You know, a software business is largely a human talent business. It's based on the intelligence of the best people that we can get to work for us. And so we know having a diverse, inclusive workforce not only helps us mirror the needs of the small business owners that we serve, but also makes everyone feel welcome in the workplace to be their full selves and really do the best work of their lives, as we say. So all these great reasons and more for why just do the things that probably make us a really responsible business, a business that cares about how we impact communities and the natural environment. There's a lot of ways that we can do that. And in the climate context, we always smirk when we hear, oh, software businesses don't create too much carbon emissions footprint. You guys aren't really the problem. My first response is we can all do something as private citizens, as employees, and we can do something every day, every second. And what matters is that we're doing something. And so I think the good news is we can take care of our own footprint fairly well, but there's a lot of opportunities to do what we do best, which is support small businesses to help them become more sustainable as well. So a lot of exciting things that we're looking forward to. That's it for me for now. Thank you.
Thanks, Anne. So when people say things like you guys are not the problem, I have to disagree, because as things stand, the digital economy consumes about 10% of the world's electricity. And the digital economy is in its infancy right now, isn't it? If you think about, say, even 20 years ago, the digital economy as we know it now didn't exist at all at that time. And if you project forward another 10 years or 15 years, everyone agrees that the digital economy is going to become bigger. So that's what I say to people when they say, oh, you guys, your footprint is very small. It's also the case that if you think about things like crypto, Bitcoin is already nearly 0.8%, I want to say, of the world's energy use, or electricity use, let's say. 0.8% of the world's electricity use. And Bitcoin is barely a thing now, if you think about the impact on the entire 8 or 9 billion of us. So, yeah. Beth, hello. Can I ask you a similar question? Why has Providence brought in sustainability into its core? Because you're a healthcare provider. Why is this important for you? And if you want to talk a little bit about that.
Great, thank you. Thanks for the invitation, and nice to be with you all. I would say the first imperative is the health imperative. So the climate impacts on health are astounding. The World Health Organization has called climate change the world's most enormous and challenging public health problem ever. And as you say, Bitcoin is just getting started. So really are climate impacts. So we're very aware of that in terms of what we're seeing already right now in the United States, where I live in the western part of the nation. Lots of wildfires, heat, extreme heat, not quite as high as in India, but very high for what we're prepared for. Smoke, etc. So one issue is the increasing health impacts, and we know that many deaths are associated with this. Part of that, the other side of the flip coin, is healthcare is fairly polluting. You just gave some interesting statistics on the digital economy. The healthcare economy in the United States is 8.5% of the nation's greenhouse gases. 4.5%, global healthcare is 4.5% of the world's greenhouse gases. And if healthcare, global healthcare were a country, it would be the 5th most polluting country in terms of greenhouse gases. So it really adds up to more than people think, especially because we're not manufacturing companies. We're not running, server farms and Bitcoin machinery, but we have very intensive electric, heavily energy dependent buildings. And a really large part of our carbon footprint specifically is our supply chain. That's a hard thing to get our arms around. That's a place where I see great potential and growth going forward. So the health part is certainly one, and that's both sides. The health impacts that we're caring for people who are suffering from, and our own pollution that is driving health impacts. The other is really a justice imperative. So we, in our health system, we house this in our core value of justice, and that's for obvious reasons that environmental pollution is not equally distributed around the world, and it's the more wealthy and developed countries that are causing more of the problem. That's not fair. It's not fair to people who are less protected, more exposed. It's not fair to future generations. It's not fair to other species. So that's a big reason as well that resonates with healthcare. There are some other advantages like recruitment. People want to work for a company that is taking this seriously because people are, rightfully worried about it. It also helps drive efficiencies. I think to get your house in order in terms of your own pollution forces a company and an organization to more or less clean up their act. And luckily, that usually saves money. So those are some of the reasons why it's important for healthcare.
I do think that's an interesting point, because when I talk to lots of businesses around sustainability, a lot of them are like, well, we are a for-profit company. How does this help us? And I do think that the software industry especially has got to find answers at the confluence of sustainability and profitability. And what you're saying, which is an efficient supply chain, is better for business, but it's also better for the planet, is a really important thing. I want to follow up on that, Beth. What are the short-term and medium-term goals for reduction of emissions in the healthcare industry, and specifically to your company? Because it can feel overwhelming, can it not? There is so many moving parts in these things. Because across the supply chain, there are emissions, there is energy consumption, stuff like that. So what would you say are your medium and short-term goals?
Well, this is picking up around the world in terms of healthcare. And so, for instance, in the United Kingdom, the National Health Service has really been a leader in this work. And they have goals that a certain amount, I think it's about half of reductions by 2027. So that's like the highest achiever. In the United States, we have some national movements. So, for instance, the Department of Health and Human Services out of the federal government just announced a goal that healthcare would reduce its emissions by half by 2030 and get to net zero by 2050. Now, there's all sorts of iterations of that across the field, and we're seeing that a lot of variation in healthcare. Our own goal of carbon negative by 2030 will not be the same as net zero. We really would not be able to achieve that by 2030, and we could go into all those details, but we do have significant goals. Really at first, it is getting our data in order, and this is where we really rely on software. Our carbon tracking and accounting, following the greenhouse gas protocol, lots of education and engagement for staff, as well as mitigating. So our goal is to mitigate 3 to 5% at least per year. And we're managing to do that. And then by 2030, we aim to have 100% renewable electricity, about a 30% reduction in natural gas. Natural gas is a problem. It's a challenge. We don't have a great solution for it. 90% reduction in our fugitive emissions, which is essentially our anesthetic agents and our nitrous oxide. And for each, there's 19 categories in the greenhouse gas protocol, and we have a plan for each of them and how much we think we're going to be able to reduce by 2030. And it's all dependent on measurement, which is, again, where a lot of the work that we've been doing in terms of our developing scorecard and database comes in. But apart from numerical and quantitative goals, we also have goals on our environmental justice work. We're scanning the communities that we serve right now for environmental determinants of health, what is out there in terms of pollution, flooding, toxic chemicals, et cetera. Who is impacted, which populations, which neighborhoods, and what groups are currently working with them, and how can we help? And then, really, I would say our overall ultimate goal, at least from the mitigation side, is to deliver climate safe healthcare. So to not have to claim that healthcare is causing 8.5% of greenhouse gas emissions in the United States. How do we get there? That's there's a lot of people working on that in healthcare. It's really exciting. It's satisfying to see that there are smart people kind of pulling it together and I think making progress. So hopefully that helps with a little bit of our goals.
Thank you, Beth. You know, a couple of interesting words that you used there. You said data and scorecards. And that I think points to how software can help with these efforts. And about a month ago, you gave this, this lecture that's available on YouTube called Healthcare and Climate Action in Healthcare is an Urgent Opportunity and a Challenge to All. I watched the talk in full, and then you talk a little bit about scorecards, and you talk about how data is important in managing these things, which gives me a good segue to get to my friend Daniel over in Germany. So Daniel, you came up with this really good way and good framework of thinking about how IT can help with climate action. And there are two simple words, or two simple phrases, I should say: of IT and by IT. Right? Of IT and by IT. So why don't you go ahead and tell us what these two phrases are, and then we'll pick it up from there.
Definitely. I actually wanted to follow up on what Beth was saying on data. And but before that, I wanted to say that I agree with Anne that we are definitely part of the solution here. There are multiple aspects to this problem. You know, corporations using their platforms and their voice, you know, consumers being responsible on their day-to-day choices, but also public policy needs to be in place, right, to hold everyone accountable. And circling back to technology itself and these two big buckets that we're seeing at the moment, right, of IT and by IT. One of them focuses on how do we make IT a more sustainable endeavor, right? So how do we make our technology processes, our products and services in the cloud, and so on and so forth, more sustainable, greener, let's say, right? And that has a whole bunch of implications: reducing energy consumption, reducing unused resources, optimizing, right, mainly. And then by IT is a slightly complementary approach, which has to do with how do we use technology to optimize or to make processes in the real world more efficient. Let's say supply chains, which in 2020 they proved to be quite vulnerable. So those are the two big distinctions that we're seeing right now in the industry. How do we make IT on its own a more sustainable endeavor, and how do we use IT to optimize, to make real work processes more sustainable, if that makes sense.
Thank you. Did that make sense to you, Anne?
It did indeed. I think for Zero, we have to think about both sides, and yeah, both sides definitely resonate with us.
What does off IT mean to you? What are Zero doing in off IT? So.
Yeah, well, when I started the what was then called our social environmental impact team in February of 2019, we said, what is the first thing that we really wanted to focus our energy on? So we had employee volunteering already going and waste programs, but we thought, even if there isn't all of the means in the near term to say fully go green, we could at least take full responsibility for our negative environmental externalities, aka carbon emissions, by investing in the highest impact environmental projects that we could find. So we invested in essentially what are called premium projects that have all these other United Nations Sustainable Development Goals, like protecting native fauna for endangered species and enabling local employment and things of that sort. So anyways, in that story, one of the things that we looked at, we don't have data centers ourselves. We build software. We also live in the cloud. We are in the cloud as a product. And so when we build our products, we use hosting services, and we asked our hosting partners, could you guys give us an estimate of how much electricity-based emissions, water-based carbon emissions we generate by using you as our hosting provider? And they didn't necessarily have all the numbers. And I think based on what we were asking them and what they were thinking about, they had essentially built tools that you'll see nowadays publicly available that help essentially customers like us of hosting partners give us a sense for how much carbon we generate by using their platforms. And so when in that process, our own tech teams built tools like, okay, if we know roughly this product is this intensive and how much it'll utilize the infrastructure we use through this hosting partner, we can also start to guesstimate how much carbon emissions will be generated from launching that feature or servicing that feature. And so those are tools that we've built internally that basically we were trying to power one team that could make a greener decision, aka our tech team and product team, on their environmental impact in a way that always updates and they always feel like they are doing something meaningful and quantified. And so we wanted to find opportunities like that across the business. But that was just one of our sort of IT stories. But again, as a cloud provider ourselves, building apps and working with third parties that join our marketplaces around the world, what we can actually build for nonprofits, for small businesses that want to go green. Those are also things that we think about more on the tech side.
When I talk to clients, one of the things they tell me is data is not always readily available. And one of the big challenges to climate action by companies is we just don't know what's going on. We don't know where the opportunities lie. We don't know how much we could reduce. So before you get into, say, complex algorithms to optimize use, etc., first you've got to know what's going on. Is that something that you've seen, Beth and Anne especially?
Yeah, I certainly have. This has been, a lot of times when people start in sustainability, they don't realize how much data we're talking about. They think, oh, it's some recycling and a couple of gardens and call it good. But it's really incredible because sustainability touches everything, absolutely everything, in a business, in a home, in a city. And to meaningfully drive change, you have to kind of know where you are. Without data, we don't know where we've been, where we're going, where to set our priorities, et cetera. But it's also enormously complex. Our health system has 52 hospitals and over 1,000 clinics. And each of those, for instance, for their energy, has different energy providers, different utility providers, multiple meters that are all need to be, connected to basically our scorecard. And we do that through our invoices. When we scrape the data from our invoices, another company does that for us. That comes into our scorecard by API. And our genius software developers, such as yourselves, make that come into the platform that in a way that we need it. And then the next step is really translating that so it can be meaningful to people. Because it's not everybody who can look at a pages and pages of numbers and understand what it's going to tell you. And so that's a real skill, I think, in terms of translating the amazing data. Getting the data is hard. It really is, especially for more obscure things like certain aspects of waste or certain aspects of water management or travel. Business travel is another thing that's quite complex for us. And then to do that, what we've developed, what our team has developed, not me, is that every month we have input data for the amount that we've used of a particular commodity, like kilowatt hours or miles traveled or meals served or whatever it is we're measuring. The cost of that, very important, because this is how we make the business case again and again and demonstrate the savings, and the carbon emissions. So every month we have an updated set of data for each of those things and a growing number of elements. And these are all part of our framework. But I just stress that it is difficult. And this is one of the things that we're finding when we talk about two other healthcare companies is people end up using estimations from DEFRA or from EPA. And that's a good way to start to get a global idea, but it's really not that helpful for watching change because you end up using the same estimation year after year. In the US, for instance, for our energy, we could use our energy grids. Those are high level emission factors for our electricity based on what part of the country you're in, but it's much more specific and accurate to use the utility-based grid or emission factors. But that requires lots and lots of calling and digging and searching and then updating. So yeah, it's very complex, but if we want to really know where we are, we believe that we need to get the real data granular as we can, automated as much as we can, so we can really benefit from it.
So one of the things I've heard is that there's three kinds of data, right? There is scope 1, or there's three kinds of emissions, scope 1, 2, and 3. Scope 1 and 2 are about 15%, most people tell me, of their entire emissions. That data is relatively easy to get. But the rest of the data, scope 3, which is 85% of emissions, is harder to get. Is that true?
Clear-cut numbers, I couldn't tell right now, but the proportion, it's as you described, right? And so I guess the takeaway here, or the core of the problem, right, is that we are as good as the data that we can obtain, right? For every design decision that we take in every business or tech aspect, right? So it's tricky in the tech industry. It's been quite a challenge, and there's been this push driven by the community, a little bit more bottom up. And now, tech companies are putting out their own, let's say, carbon calculators, or they're being a bit more transparent on that data. But still, it's super challenging because many of these factors, they get lost in, let's say, in a data center, right, or in a set of data centers. And when you want to have the granularity of what your impact is, among thousands of machines that are being shared by thousands of clients, running multiple workloads. So getting that level of granularity, to me, it seems it's the biggest challenge for cloud providers, but it has proven to be useful for the community to push them to get the data, right? Because until 2 years ago, there was nothing, right? Actually, in Thoughtworks, we have our own internal tool that we've released and made it open source for estimating carbon emissions of cloud workloads. And it's using what we call cost and usage data in the cloud, right? Because it's the best that we get at the moment, right? But we need more. We need to keep refining this so it gets more and more accurate.
So given that our audience is mostly technical people and software people, I want to dig into that aspect a little bit over the next 5 minutes or so. Daniel, I'll start with you. So if you think about the software development process or even the life cycle, there's many areas where we could make it more climate friendly. For instance, you could have a less energy intensive architecture. Your algorithms, ML algorithms, can be more efficient, or your cloud storage can be better, or the design of a software product can be such that the end user's browser or the app consumes less energy, and on and on and on. So can you break this down to us and say, what's the area that has the most promise if we want to make IT more energy efficient?
That's a hard one, but I'll try my best. So the way that I like to break this down is in a couple of dimensions, let's say. So when we talk about the software development lifecycle, we can start thinking about, okay, we just covered cloud, right? And in there's a whole bunch of things that we could do in terms of being more carbon friendly. Problem is that, not a problem, something to note is that most of the things, in order to keep this optimizing mindset, they're not new, right? Maybe what's new is the context that we're in a climate emergency, and we need to change a little bit of the culture that we have as technologists. I granted, that can be new, right? But then some things such as algorithmic efficiency, or these kind of things, they've been around for 50 years or 60 years, right? And how to optimize things. So the cloud certainly looks promising to me, given that I believe the numbers are, so the global consumption in terms of electricity, it's slightly higher already than the airline industry, which is concerning how it's, increasing. But then, as I said, you can break it down and you can touch other aspects of the software development lifecycle, right? Not just cloud and data. Let's put data there for a sec, right? We can think about processes, right? And techniques that you use for developing software. And you may know that at Thoughtworks we have some experience with trying to reduce waste in the way we develop software, for example, and some of these agile and extreme programming techniques that have been around for a while now, that also helps. Then you can think about more with a product mindset, right? So we're thinking about optimizing or making design decisions that are more sustainable, within my tech organization, let's say, right? Now, can we do something to empower our users so they can make more carbon-aware, carbon-friendly decisions while using our products and services? You can see some of these things already happening in some products, right? You have like e-commerce platforms that are tagging, product A is a more sustainable option than product B, or flight search engines that are saying this flight will emit less carbon than this other flight. That's shifting a little bit the decision and the education towards the user. I would break it down like that at the moment. Yeah.
Interesting. Thank you. That's very good. So in your answer, I felt like regardless of what work you do in software, you have a role to play. So if you're an infrastructure person, you could think about how to reduce the emissions of cloud. If you are a design person, you could think about how to nudge consumers to take action about this. Maybe accept this product over that product because one product is more friendly towards the climate. Of course, developers can think about minimizing waste in the software development process itself. Likewise, product people. Excellent. I think that gives us a good place to pause for a few minutes and ask if people have any questions. So we'll do the questions for about 10 or 12 minutes, and then we can come back and summarize the discussion. So Krishna, Swapnil, and so on, I don't know how you're planning to do this. Should people send questions over chat, or what do you think? Or should they unmute themselves and ask a question if they have one?
So we have asked the audience and the participants to pose their questions in the Q&A.
Yep.
So as we have these questions, we'll pass it on to you. We do have a question from one of the attendees. Yes.
You talked beautifully about the challenge in accessing the 85% data. And from what I understand, that data is actually the data that you need when you're fielding your application. The 10-15% initially is through the pilot surveys or your initial approach to developing the application. When that is the case, do you mind talking a little bit about why that 85% is a challenge? Because the data is the same. It's just maybe the reach, or maybe what my thinking is that maybe organizations get tired after 15-20%, and the application is supposed to run on its own and collect data. That's how I approach it.
Thank you for the question. I think we do need a little bit of a primer on scope 1, 2, and 3 at this point, because the 85% of the hard to collect data is qualitatively different from the data that's internal to the company. So I want to ask if Anne, Beth, or Daniel would like to give a primer on scope 1, 2, and 3, and then talk about why scope 3 is actually hard to collect.
Yeah, I can give you a sample from just what our own internal operations looks like. So when we wanted to go fully carbon neutral and continue to reduce our carbon emissions year on year in absolute quantity as well, we had to know where we stood, like Beth mentioned, to figure out where we should set our aspirations for how much of our climate footprint we reduce, how much we help our wider value chain or network of influence, how we can help them go greener as well. And so when we looked at all of our options to calculate our current footprint, we said, what data do we need? And it looks like about 520 plus sources of data every year, every month, depending on the good itself or the item. It could be every week. So depending whatever the invoice, for example, looks like, or that utility bill. And so that's 520 data sources that without IT would be quite a manual exercise just to house them in one place, nonetheless, make sure they're kind of the freshest that they can be and things like that. But also once we put all that data in one place, the people that use it, they touch different parts of our business. So in scope 1, 2, and 3, essentially the first two, you have more direct control over whether or not you create those emissions by maybe making different choices. But scope 3 is all about the things that you don't directly control. So your indirect influence for us, that's our suppliers. There's lots of small and large businesses in our supply chain. That's our small business customers. And so we know that for them, it's really hard to figure out what their own carbon footprint looks like, nonetheless, what they should do about it. And that's why we chose, like others were mentioning, there are companies working to create solutions to help their own customers go green as well. So we're doing that for small business. And the way that we do it is based on our core accounting experience. We have zero bank fee data, or what companies or small business owners spend their money on. And we use that spend-based data to calculate roughly how much carbon emissions is generated from the goods and services that they procured as a small business owner. And so with that, we have 3 applications in the UK that do that. We want to enable that in our other regions. But really the longer term question we ask ourselves is, if we truly believe the future of accounting is non-financial accounting, like carbon accounting, there's all of these ways that climate especially will change everything that we all have to do each day. And there's a green option of, or there will be for everything that we essentially need to do in some form. And so we think about what a small business owner would need in the future to manage their financial and non-financial considerations when making decisions as a small business owner. And so a lot of them want to do it now. They just know it's really hard, and it takes us tens of people and hundreds of thousands of dollars and all that to do what we do, and we're not finished. It's going to be an ongoing project probably for the rest of the company's duration. So for a small business owner, we hear something like they probably have to spend $30,000 a year just on consulting hours to go carbon neutral, nonetheless actually switch to clean energy or install a solar panel or whatever the case is. So it's not an easy feat for our customers either.
Yeah, it is an ecosystem problem, isn't it? Because someone else's scope 1 and 2 is your scope 3. And unless everyone has got their data in order, it's actually hard to do this well. So there is an opportunity to be creative around how do you enable smaller companies, especially if you don't have the resources to do these things and the mandates to do these things to do better. So I do think that Zero's work in that aspect is particularly important, because as you say, you reach so many small businesses around the world. There's an excellent question on Q&A from Sushmita. She asks, can we build products that are sustainable and profitable at the same time? Amazon will keep luring us with things to buy. Adding a carbon footprint to our purchase will be the same as cancer warning on cigarette packets. Cigarette manufacturing never stops. This is a topic I have very strong views on. So allow me to say something for a minute and then we'll go to our panelists. So this also speaks to the need for regulation, because smoking rates in the West are down dramatically in the last 25 years or so. So what really happened is that the regulators came in with a lot of good ideas. For instance, you cannot smoke inside a closed restaurant, and you cannot sell cigarettes to minors without ID. You cannot have cigarette sales next to schools, stuff like this. And all of these things actually did work. And in a similar way, we definitely need more regulation. But having said that, I don't think it's quite one or the other. Even when there are commercial imperatives, as Sushmita points out, there are things that companies can do. We cannot leave it all up to regulation. And I know that this is an area that Beth has talked about in her talk. So I want to go to her and ask, while regulation is important, what are actions that companies can take? What are examples of actions that companies can take that are both profitable as well as good for climate?
Thanks. Yeah, it is really important question. And all of us are a little bit in the dark because we don't know, we can't even make good consumer choices because it's not clear. And one of the reasons as you suggested, that it's not clear is it's not regulated. And that also means in a way that it's not agreed upon. So people just say what they want. If we don't have some sort of certification process or really just, extreme transparency so that I could say, okay, let me see your data, then I'll make a decision about how I think that's going to impact the climate. Because right now it's, I think people can just make claims. It's almost like the nutrition labeling. People can still just say, oh, it's natural or it's organic or whatever. Right. And so without better definitions and more agreed upon definitions, I think we're going to be kind of in the woods for a while, in the forest. One of my takeaways from COP26 this past year was that there's a much more intense interest on this very topic of getting on the same page in the corporate world, particularly because they're being called to task, sooner than the nonprofit world is. Another thing that's happening in the United States right now is the Securities and Exchange Commission is putting forward that businesses need to report their scopes 1 and 2 transparently. Other parts of the world are ahead of the United States in this regard. But you can imagine without that even being reported, it's very hard to tell. It's very hard to make an informed decision. But the second part of your question, what can businesses and producers do? I really think it is about being transparent. It's about reporting publicly. It's about explaining what we're doing. It's about posting it, and it's about asking people for feedback, because that invites people into almost the interior of your decision making. That helps build trust. And also, I think we just have to say to the world, I mean, we all know it. We don't know right now. We're in this gray period that will work itself out, but we need to both push, as some of you have said, we can push ourselves and others, and also be patient with the fact that it's not black and white right yet.
Thanks, Beth. In effect, what you're saying is we need to have agreed upon standards.
Mm-hmm.
Everyone needs to say that this is what each of the terms that you're using means. And data needs to be trustworthy, and there needs to be agreed upon benchmarks for things. So this is, of course, a problem in every industry. It's also a problem in the software industry. And Daniel, the GSF, the Global Software Foundation, which Thoughtworks helped start, exists for that very reason, right? To bring some standards into this space.
Yes,
can you talk
correct.
a little bit about our efforts to bring in standards and processes and agreed upon benchmarks for these things, please?
Yeah, there's been some journey and some progress since the foundation was created in May 2021, quite rapidly, I must say. So everyone is eager to contribute and to drive forward some of these initiatives from the tech community. So as of right now, one of the most promising projects that the foundation has is this framework that is called the Software Carbon Intensity Specification. And it's this attempt, formula-based attempt, let's say, to come up with a standard on how to measure the carbon intensity of a software application or a software component. And it's currently in alpha, and the ask for the audience is that everyone can go to the GitHub repository, get involved in the open issues and the discussions, and take it forward, because it needs a lot of thinking. You might have heard us already talking about data and how sometimes it's hard to get. That's one of the things that we need to think and keep thinking when we try to approach these standards or these frameworks to come up with a score. So that's one thing. And, before we got to this point, and maybe separately at Thoughtworks, we had our own way to do this guesstimate using cost and usage data, right? It's probably not standard as it is right now, but it's a consistent approach on how to measure being cloud agnostic, right? How to measure software components in the cloud being cloud agnostic, right? Whereas if you use each cloud provider, then it's like you're measuring apples and oranges, perhaps, right? It's slightly different. But shifting back to the foundation, we now have this initiative that we'd like to, see being refined and progressed. Yeah.
Thank you. We've got about 5 minutes left. So what I'm going to do is I'm going to ask the three of you the same question. It's more or less in conclusion, and then we can call it a day. So the question is about climate doom and what to do about it. So there is all this information that we receive from the media on a daily basis, right? The oceans are warming, you're seeing the effects of climate change in Delhi, certainly this summer, but in California, as Beth pointed out, in Australia, the Great Barrier Reef is bleaching. The effects are everywhere. And the solution also feels overwhelming because we need the whole of the global community to agree on standards. We need to collect the right data. The solution to all this is social, it's political, it's technical, it's economic. It's the quintessential systems thinking, dynamic systems problem, isn't it? And the solutions for each industry looks different. So if you think about this, several emotions come to you. One is that, oh, it's a really hard problem. The second thing is there is a certain sense of we can't do anything about this. The problem is too large for us to do something about. So these are natural emotions to have. And I must confess, I have these emotions from time to time. Yet it's important to stay optimistic. And yet it's important to think about how can we contribute? Where do we start? So I want to ask those questions of you. How does one stay optimistic? And how does one work out where to start and how best to make a contribution? So Beth, I'll start with you, and then we can go to Daniel.
Well, yeah, what a time to be alive, huh? That's what I say, because from all we know about human history and even before humans, we've never been in a situation like this of our own making. I think it's a perfectly rational response to feel overwhelmed. And we think about this a lot in healthcare because the mental health aspects of climate anxiety and, suicide. I mean, it's really tough, especially for folks, we're told age about 18 to 25 is a particularly vulnerable period. And I think that makes sense. And I don't fault anyone for feeling that way. And at the same time, I don't feel that way. I don't. I'm quite optimistic. I'm optimistic for a few reasons. One is, of course, we can do something about it. I just don't feel that way, that we can't do anything about this. I mean, it's humans who got us into this. I think humans can help get us out of this. It's gnarly, it's complex, it's nothing anybody can do by themselves. And as you say, it takes multiple things happening at once. But in fact, multiple things are happening at once. It's really exciting to see the solutions that are happening today and that people are thinking about, and that smart developers such as yourselves and smart physicians and nurses. And I find that energizing. I think for myself, I feel better when I'm taking action. So I tend to be a worker. I want to dive in. I want to understand. I want to help figure out solutions. That helps me feel better. Another thing that helps me feel better is working with like-minded people who are also solutions driven. I think all of us can contribute. None of us can do it alone. And I think in a certain way, I've felt like, if I'm going to live on this planet, then I need, and for all of my life, I've seen the environmental crisis. So I need to be helping. That's just part of the deal. If I'm going to benefit from this planet, I need to help the planet. And even though the problems have arguably gotten worse, that feeling in me hasn't really waned. So it's just a matter of, yep, it's challenging and it's also really satisfying to be able to work on it. So I appreciate the opportunity. Thank you.
Thank you, Beth. Anne?
Oh, that was great, Beth. I was like, I could listen to you keep talking. Oh, I hate to go after. No, I think it's so much to think about, but I think like if there's one cause that could unite all of humanity into a single effort, it's climate change. Even in wars, there's always sides, but in climate, if we're all on the same side, it's probably a unique experience that all of humanity, if we could really get well coordinated, could put all of our effort across cultures and across countries of intelligence and try to solve this thing. I totally think it's possible as well. I just think it's probably the largest human, feat of coordination ever. And we're still on that journey, and how quickly we can, get it all together and whether it's in time, it's all kind of relative, I guess, but at least we're doing something, and I think just like Beth, I always feel better when I'm taking action. Like, and if you sit there and kind of find yourself saying the same thing, venting about the same thing to the same person over and over, and nothing changes, why vent about it to the same person again? Tell someone that might care, or, who might be able to do something about it. And if you tell enough people and you just do some small stuff, eventually stuff has happened and changed for the better. And, I think just doing something, I'm like, okay, if I just do everything I can do, that's all I can do. And I just do something every day, whether it's my core job or in my chats with friends, I think all of that helps. Just being here at an event like this when it's completely optional is you guys all choosing to learn something today that hopefully will inspire action. So I think just caring and showing up and just trying to do something, no matter how small or big, is probably the main thing that we can all do. So yeah.
And do something in your core job on this planet. Because one of the curses of the tech industry is that some people in the industry have too much money and they think that colonizing Mars is the solution to this. No, it's not. You've got this planet to live on, and you've got to do something over this planet. Sorry, pet rant on the side. Daniel.
I think everything was beautifully covered already by Anne and Beth. I think one thing that I can add is I like to fall back to the Agile Prime Directive here, right? It's we do the best we can with the information we've got in the context that everyone is, right? And I think the hard part of this problem is that, as humans, it's pretty hard to see, beyond what's in front of my feet, right? And this is a problem that is intergenerational, right? So for me, that I have a limited lifetime, right? How do I see 100 or 200 years into the future and try to help with that, right? And there's a nice, interesting podcast out there, episode. I can't remember from which podcast, but apparently there are two interesting ways to look at the problem and at the solution, and they put it like this. One of them is look at it as a prophet, and that's everything that you get to hear in the news. We're doomed, everything is lost, and that hope that would trigger some action in the community, so everything is not lost. And a wizard, which is a completely opposite approach, in which we're a civilization that has invented the wheel, fire, and satellites, and space travel, and whatever. So we're gonna be fine, right? And technology will save us. In that spectrum, we need to find some balance, right? So it's toxic to be, be fed with news every single day at every single minute, and everything is not doomed. But relying solely on technology, that won't save us. Yeah.
Excellent. So as Beth mentioned early on, these questions are also about, they're just larger than just what you do. It's also connected to various things that are going on in the world. So I always find it useful to remember three words: educate, organize, and act. Educate, organize, and act. First, you've got to learn about the problem. And learn about the problem as we are doing now, of IT, by IT. Organize is, the problem is too big for us to just act by ourselves. So find the people, find the community who can do this better, and act by improving your daily work, but also by holding the powerful to account. As a data scientist, as a developer, as a product person, you've got more power now than ever before, because the digital economy is a huge thing now. And our profession of software is very prominent in the world. We are some of the most privileged people in the world. And what we do touches every aspect of everything in the modern world. And if we learn how to develop environmentally friendly software, if we learn how to do better visualizations that help managers make better decisions, if we are better infrastructure people, if we design products that minimize the impact on the climate, then I think we've done our bit. So we are 5 minutes to the hour, and we will leave it there with a huge thank you to Beth and Daniel for joining us from across the world. It is a global problem, and Daniel is in Argentine, who lives in Spain, but now is in Germany, Anne's in Australia, Elizabeth is in America, and I'm in India, and our audience is in India. It's a global problem, global people. Hopefully there's a global solution too. Thanks, everyone. Bye-bye.
Thank you so much.
Thank you,
Thank you,
guys.
everyone. Have a good one. Bye.
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 Beth, Daniel, just to hold, sorry to hold you for a couple of more minutes. We have a question from one of the attendees here. I mean, okay, if it's open, Daniel and Beth, since you stayed back, we can answer that.
Okay. Yeah, so I have a question related to the, I mean, when we spoke about, for most of the things, data is not available and standards are in alpha, but there are still few things, right, for which we can still calculate what are the emissions that we are doing. And we are also working with things like vendors, and these things can be divided into the multiple areas that working with a vendor, then probably where our offices are, or the cloud providers that we're using, at which region those cloud providers are, depending upon the different kind of a data. What are the things that we're doing today to reduce the carbon emission or being greener, more greener? Are we just waiting for more data, or have we started doing something?
I can speak to that a little bit in healthcare, if that's helpful. The whole mitigation strategies are widespread, if that's what you mean, in our operations and buildings. And we use a model called We Act, which is waste, energy, water, agriculture, food, chemicals, and transportation, working on all of those to drive down emissions as much as we possibly can. With our supply chain, which we've talked about a bit today, it is difficult, largely because there's not transparency, and many of our vendors haven't been measuring their own emissions. So how can we know what they are? We have 60,000 vendors, and we spend about $8 billion a year. Nearly impossible to try and get the kind of information we need, but we're starting with our biggest vendors, our tier 1 suppliers, and actually asking them to measure and report their scope 1 and 2 emissions, which, as was said, will be our scope 3 emissions for them. Then we're also working with them, we'll be working with them to drive down theirs. This is both the frustration and the beauty of the greenhouse gas protocol. You have to work together to make progress together. And so we're dependent on the vendors, our vendors, to drive down their emissions and vice versa. And I would say, at least, you know, we partner with Microsoft. We're both located in Seattle, and we partner with Microsoft. So we've been learning about some of their strategies. They are literally helping their suppliers purchase renewable electricity, really transforming the energy market, you know, around the world, not just in the United States. That's a way that the greenhouse gas, their own commitments are driving them to help drive down the emissions in their supply chain. And so that's a good example, I think, of how that greenhouse gas protocol is intended to work. But it's difficult because we're not all at the same place. Not every company can do that. And in the meantime, like I said, we're still in this murky period where we don't really know. Jenny, what would you add to that?
From the tech perspective, I agree with everything you said, and from the focusing more maybe on tech organizations, I think so as we go into this, as we push for more transparency and more refined and accurate data, companies are putting out some guidelines or heuristics or even some patterns and principles on how to become more and more sustainable, right? So in a nutshell, if you want to emit less carbon, probably you want to reduce the usage, the energy usage in your cloud, for example, right? And then that can be broken down into many multiple aspects, right? So you start thinking about, should I run my own data centers or should I move to the cloud? And from the cloud, should I use this type of managed service or this other type of, or should I build my own thing, right? And when we talk about compute, should I go with this type of, instance that consumes X amount of energy based on the CPU and memory, or this other, serverless compute option? And, and these are kind of like, I don't know how to put it, maybe like a decision tree kind of, way of approaching it, right? They're heuristics and guidelines that are being put out there while we wait for more transparent data or more accurate data. That's how I would put it right now. Hopefully that's useful.
Yeah, thanks, Derek.
Hi, I got one more question for you. Beth, you mentioned that you're pretty optimistic about achieving the goals of the climate reduction with the joint effort. So, I mean, I know that there was a discussion on the COP26 summit that using a combined global effort, we should be able to reduce the carbon emissions or limit them to around a 1.5 degrees centigrade rise. Do you think that is actually achievable in a realistic scenario, considering the diversification of the entire world?
Yeah, I think every day we don't make significant progress, that is less achievable. Because that means significant change, really reducing half of our global emissions by 2030. That's enormously complex. Every month that goes by that we're not doing that and not turning that ship, it gets less and less likely. So I can't tell you that for sure, but I also don't think we should just rest at 1.5, because if we get to 1.6, 1.7, the COP26 also said that the commitments today would get us to 2.4. 2.4 is devastating. We don't want to allow that. We don't want that to happen, but it's better than 2.7 and it's better than 3.0. So this is kind of on a scale. We're going to do as well as we can. And I hope that all of us on this call and every single person doesn't lose their own energy to work on this, because it really is a matter of saving the world. I don't mean to be overly dramatic, but that's what we're up against. So will we get to 1.5? I sort of doubt it, because we're not making fast enough progress right now, today in 2022. Does that mean all hope is lost? No, we just got to keep working and realize, okay, we're going to do everything we can to try and keep it under 2 or under, 2.3. I really hope under 2.
Yeah, it's also the case that this is a continuum, right? It's not like at 1.5 something absolutely dramatic is going to happen. 1.4 is pretty bad too.
Yeah.
1.5, it's a number that gets used a lot because it's easier to keep in mind than like 1.392. But 1.392 is pretty bad too.
Yeah. 1.1 is pretty tough. Let's face it.
Exactly.
Definitely.
But, the world needs solutions, but it also needs socio-political action. Mm-hmm. Eventually, as we talked about, regulation is important. This is not trivial. Yeah. It is not up to only individuals or only companies.
Right.
So as a professional, we've got to learn how to improve our work, but we also in our personal lives learn to hold people in power accountable.
Yeah, I was going to say, when you all were talking about driving down emissions in IT, another big piece is advocacy for clean energy, because you can work on it from efficiency and bring down your energy use, but you can also put that down to almost 0 emissions. And that takes political will, and political will takes people like us still out there talking about it.
Yes, and it's connected to everything in the world, right? It's connected to consumerism. It's connected to availability of public transport, for instance. You know,
There are
so
some.
are electric cars the solution, or is public transport the solution?
Yeah,
So,
totally. I was going to say something like that.
Yeah, and electric cars have lots of batteries, which are made from minerals that are mined in horrible conditions. So that's a connection to social justice and those sorts of things that you talked about there. We can go on about this all day, I think. Should probably call it a day. So Krishna, Kunal, everyone else, thank you for hosting this. Thank you for coming. And Beth and Daniel, thank you for your active participation as well. Bye-bye.
Thank you too.
Thank you, everyone.
Bye-bye.
Bye-bye.
Thank you so much, everyone, and Daniel and Beth and Nagarjun. And it's almost past 12 for Beth. So yeah, special thanks to her. We cannot agree more, right? Well, points of experience that we have. And yes, sustainability is not limited to only one region, that is tech. It is like have a wider range, be it health, be it social challenges, be it anything. And we have our next speaker, Kuldeep Singh, the head of XR practices in India, and he will be presenting a talk on sustainability in XR. Over to you, Kuldeep. Thank you.
Hello, everyone. I'm Kuldeep, and I'm heading few XR related initiative. Yeah, XR will define what exactly XR is. So we'll introduce with XR what we mean by sustainability, what are the use cases we can explore XR use cases for sustainability, and what are the concerning part of XR or metaverse today, where we are going and where we are heading. So, okay, let's continue. Yes. So we'll talk about the definition of both these terms, how they are linked. This session is not primarily about providing solutions. It is more about creating awareness, what all things we really need to think when we are evolving and when we are calling ourselves for innovative solutions. Let's see what XR is. XR, the term XR is taken from extended reality. Anything we want to extend of the real world in form of some different ways. There are multiple types of extended reality. One is, for example, augmented reality. Augmented reality is when we augment the real world. We overlay digital content on the real world based on the context, based on the devices we have. To do that, we need some see-through glasses or some camera or something like this, where you can see the real world. This is a smart glass. You can see the real world, and you can augment a lot of things. When you wear it, you will see the world differently. Actually, you are augmenting some digital content on top of real world environment. You might have seen all our speakers, they were using some background picture in Zoom. That's also augmented reality. You can do a lot of stuff. You can show yourself you are at some beach and while taking a call from your home. All this is extending reality. You are changing the reality. Another form of real extended reality is kind of these devices. That is virtual reality. You don't see real world. When I see this, I can only see the virtual content, digitally computer generated content in these devices. And that's where virtual reality comes. Next, another thing is another popular term coined by Microsoft, that's mixed reality. Mixed reality is when these devices are becoming advanced, they understand the environment, how far this environment, when I'm moving with this device knows with respect to environment in which direction this device is moving, at what speed, and all these information. So I can really interact with the environment. If I switch off the light, the content in this device will also get impacted based on the intensity and sensor involved in these devices. So these are little advanced device they call mixed reality device. There are a number of such devices like Microsoft HoloLens. In fact, this AR device is also MR here. It can detect, it can track your position. You can place a virtual object here and you can roam around that object, that virtual object. Virtual object will stick to the world. So that's the kind of interaction is possible. That's MR devices. Another device, let me introduce you. XR device is this. This is also, by the way, XR device, fully capable to do all the things what you can do. If you search on your phone Tiger, if you're using Android, you search your phone Tiger, you can bring Tiger at your home and just right here. So your phones, most of the phones supporting already XR. Even VR, you put these phones in these devices. Then it becomes a VR device. The same, when we run any application on these devices, it runs in same screen. It's split it into two parts. That's how eyes detect. Eyes are also two cameras for us. Left and right camera, and they eventually take picture of the real world at certain frame rate. And that's how these devices are also simulating our eyes. So our mobile XR is another form. Then comes web XR. Yes, our favorite websites, JavaScript tools, we can enable them XR. We can enable our JavaScript based tools in XR based websites, we can make them. Another form is naked eye XR, like heads up displays. You can project things on our car dashboard, in windscreen. There are a number of the new cars are having these HUDs available. You can see map just in front of while driving, and all the extra information you can see. So yeah, so these are the kind of, and other form of XR is the smart mirrors. You might have seen in gym, different gym are now introducing smart mirror. You can stand and the mirror will guide you what type of exercise you should be doing. The mirror can count you all the reps and everything that you're doing. So that's all about different form of XR, extending reality. Let's get into now other aspect where we are heading. So we all have some sort of data. Like Nag, and in the last session we talked about data, how data is affecting. We all have data attached to us. I have my name, I have designation, grades, in which company I'm working, my email ID, what car I'm driving, where I'm staying, what all properties I own, all those things, where I'm traveling, what are my interests, what are the things that I don't like everything is my data. Like data using which I can be referred. So that is called metadata of me. The data connected to me, let's call that data, and that network is intranet. Now, similarly, you all have your own data. Now, the connection between your data and my data, that is a network, and lot of forces are going to actually strengthen that network more and more. And that's where we are getting into metaverse. people are talking metaverse today. That's where we are getting more and more connected infrastructure, connected human data is being exploited. So that's where in metaverse, it is being defined like our avatars, our data will play, can replicate us. My look and feel, my interest, my voice, everything can be replicated, and my data can really talk to your data. So that's how the virtual avatars, virtual replica of us can really talk to the world. I can represent, I can have multiple of my identity, and those identity will talk to your different identity. I may be player at some point of time. I may be a social person at some point of time. I may be something else. So all these things are becoming common in metaverse. Different, all the digital assets we are talking, digital properties will be coming, currencies, the way people survive, all these things will be changing. That's how metaverse is being talked. How much is the reality? That's a separate story. But if you look at the characteristics of metaverse, that is about metaverse has to be open and independent. It has to be one and only one, interoperable for every different type of technology businesses. Everyone should be able to use metaverse. No single company should be controlling metaverse. And the metaverse has to be self-sustainable, so people can earn there, can survive there. That's the characteristics of metaverse. We are still years. There are so couple of years still need to go to reach there. Maybe 10 years, maybe 20 years, don't know. But that's the end goal of metaverse. Once we reach there, it will be like internet today. All these characteristics I talked about is there with internet. We can use, everyone can use internet. And with internet, we are doing a lot of businesses. That's how the metaverse is being built. Today's website is tomorrow's metaverse or near term. That's how people are thinking. Every company is trying to build their own metaverse. They have their own definition that suits their business. Microsoft has their own set of definition. Meta has its own. Meta, Facebook, everyone knows. They have their own narratives. The companies like Niantic, they have their own thing. But if you look at the today's state of metaverse, it is primarily evolution of different technologies. Primarily, if you look at all these different components, these are playing or enabling metaverse or taking us closer to the real end goal. Like evolution in IoT, evolution in blockchain technology, evolution in 5G, 6G, cloud, AI, and XR is still the core, will remain core in metaverse because of today everyone is struggling to build a new type of experience. We have been building this 2D screen from last 30, 40 years. And everyone is looking for different kind of experience. And now the evolution of these technology are actually enabling that kind of experience. You have your hands are to do work, not really to do click on something. You can do click by just by looking at it. You're thinking I need to click it's all digital generated content. If a digitally generated content is there, of course you can program that the way you want. If I'm thinking that button should be clicked, it should be clicked automatically. Why I need to go and click there? It's all programmatically done, so program can be written that way. That's how new interface and interactions are being thought of. That's where we need to think sustainability aspect of this. It looks very jazzy to think like, yeah, it is great, or may look scary as well. So before getting there, pros and cons of the technology, we need to understand what exactly the sustainable development is. I was looking about it, and I found this article, 3-pillar definition of sustainability. it's all about different. Sustainability is not just environmental sustainability. If we don't produce plastic, then we are good. It's not that. All three pillars need to be balanced. Then only we can call sustainable business. Three pillars: environmental, economic. Of course, we need to earn. Everyone needs money to earn to survive. Socio-political sustainability. So this is how these three pillars define. They intersect each other. So businesses which creates equitable, earn enough and create a equitable society, equitable economy for society, and such that it is making that business viable for environment, and making that environment bearable by society eventually. Looks very complex, but this is how sustainability is. When all these three pillars are balanced together, then the sustainability, we call sustainable business. So we need to judge our solutions against all these pillars. So let's now get into different use cases of XR. Yeah, so the first use case is location agnostic work environment. We have seen its need in this time. From last more than 2 years, we are struggling to work and adapt to these new type of environment. And now we are trying to come back to office. No, and that's actually hard now to bring back everyone to office. New type of environment is being built, hybrid work culture, etc. So that's where XR can be really XR or metaverse kind of use cases can really bring the capabilities of both world. Virtual world, Zoom, etc., or collaboration, remote collaboration, all have their pros and cons. XR can bring capabilities of both the world, real world as well as the virtual world. It can claim that everything can go digital, everything can be replicated. This office environment, these tables, your replica, your avatars, everything can be replicated. So we really don't need a physical space to join this type of meeting. We can be doing this meeting in metaverse or some virtual event conferences. Part of it is already happening. Only few of us are here physically, but many you are able to meet people from world. XR can claim that infinite and interoperable space. We don't need to limit ourselves in only this much audience. If you are building a virtual event, I can accommodate any number of, as long as my platform can support, I can support any number of people in that. Remote collaboration is possible. I can make expert come to your place without actually traveling and helping your problems. Another thing we might have noticed, it may have, if everyone is going at remote places, now if you see our team structure, some people are really working from really remote locations, from hill station and all. So the density is distributing. More the distribution will, more the development of the local level will happen. What are the advantages? It says I don't need to carry all these type of laptops. I can do all the things in just this. I wear it and it can show me all the desktop, PowerPoint presentation, whatever I can do directly from this glass. And in future, these are coming more and more evolution of these. So I might be carrying lesser hardware or lighter hardware are coming. Lesser power consumption for mobile devices. This may be very subjective, but if you look at this type of screen, this device can show you 3 times of the screen. If you charge this device for 3 hours, it can run for the videos for 2 hours. It's just a mobile. It is connected to mobile phone. Just like you keep your mobile charge, full mobile charge, it can run 3-hour movie, you can run. So the power consumption will be much lesser than these. And bigger size of resolution, better resolution, and at your comfort, you're sleeping, you can bring those screen at wherever you want. So there are different things. For designing products in 3D, industry need to actually waste material. They need to build 3D models of the actual physical object to try them in certain things before actually they come to production. If I need to build a car or parts of a car, to fit that, someone need to build a demo, dummy models. So a lot of material wastage goes in. But with XR, you can do all these things without really building any real 3D products. You can try actual size, whether, for example, whether this table will fit here or not. I don't really need a table here to try. I can virtually try before actually all this setup. The whole setup I can try in my classes. So less material wastage, less travel, less wastage. So this can really be a great use cases, can be used in different use cases for building sustainable business. Other use cases, training and awareness. Training and awareness about sustainability, of course. If we need to train today's generation or next generation, we can't train them with the traditional way of documents or traditional books and papers and chalk and all. They are already using, if you look at the kids, they are better than us on gaming. My son is much better than me on certain games. And still I say don't play, but that's how it is. No matter what you say, these new generation, it's hard to train them on those methodologies. But it's at the same time, it is not that everyone should jump into these new type of technology and start leaving everything behind. There are always positive aspect of the traditional thing and also the positive aspect. So we need to balance out things, how we really can make existing thing more interesting. So today's books are coming with a lot of AR content on top of it. Even NCERT book I have seen my 6th class son, they have AR app. I was surprised to see it was not a great app, but still there's a QR code in the first page. You scan it and you can open the chapter, every chapter, videos, etc. directly coming on the book. And 3D models are popping up and all. This is all NCERT is doing. And we are thinking XR is not flying. So that level of thing is going. Other aspect, if we see, every day, 10K baby boomers are retiring every day for next 20 years. Baby boomers are, I think, 1945 to 60s. That was those people are retiring. So skills are going with them. How to retain that skill, how to onboard those people, that's a challenge. 75% of global workforce will be millennials by next year. Millennials is still, I would say, old. They will be 40 plus by next year. So even Gen Z, I would say, they will that will also be challenging. Other reason for bringing these use cases is work complexity is increasing. There are compliances, new compliances need to follow up. Safety and compliance requirement are coming. Humans need to work with machines. So training for that kind of environment needed these kind of device. Of course, for sustainability, for economical sustainability. I'll talk about other aspect concerning aspect of this. Let's take the next use case is property definition is changing. The intellectual property definition. It's no more. It will be no more at least the same as the occupying, owning this building or owning a home or owning something. It is changing. When you are buying a car, maybe you will also be buying an NFT for that car. And NFT cost will be more than your car. You may be buying only a certain portion of that NFT when you are buying. So these type of new business model might be coming in future. So the content economy is growing. Today, there are lot many YouTubers, and you look at them, they're earning enough. And what they do, they come in the morning, they think what differently they will do, what different videos they will make. I know one of my friend, he made a video, he put his old car, dig the earth and put his old car there, put there for 1 month, and after that they use JCB to come that car out. Just that video. Millions of views of that videos. I'm talking about content economy, how YouTube created one platform and how that content, that YouTube is now popular for content. You do lot of things. Here, metaverse type thing or XR is heavily dependent on content. You're this building, 3D content of this building. When you're buying a car, 3D content of that car, who will own that digital content, all these things are coming. So definition is changing. Today also a platform like Sandbox, Decentraland, you can buy land, you can build house there, virtual house, everything, sell it or rent it to someone. You can invite your friends to join a party there. Okay,
Next YouTube.
yeah, and things are changing. Advertisement is changing. The same building, you can have advertisement at different people will see different advertisement at same building and same poster. When you are using these glasses or smart things, they will see different. So the whole advertisement paradigm is changing. Or they may be, there are companies like earlier there was a social media strategist. Now there are metaverse officers are being hired to handle this. So there are things are changing. NFT is one of the things that's also coming up. Another great use case for society and political angle, I would say, since everything is virtual, you might have heard that recently there was a marriage in India. The father of girl bride actually joined that wedding in metaverse. The father is no more.
Right, 2 years.
Some people say it looks scary, the person is no more, but think about that girl whose father joined her marriage and father was no more. But this type of thing is coming. Say example video you see here, this mother is meeting her daughter who was no more at that time. Due to leukemia, she died. She was able to touch her. There are gloves, etc. being developed. You can really get a haptic feeling. When you touch a virtual object, you can get a haptic feeling, like your butt, it presses. So you'll feel like you're touching. These type of developments are happening. Who have not seen movie Avatar? Especially able people can have ability to do things. A person in Hero in that movie was specially able, but in Avatar he was perfectly doing all the things. So XR can bring the real power of being human. That's how it is being taught. Other important aspect is dose. Dopamine, oxytocin, or these four chemicals in our brain. They are reason of all the things. When we meet someone, we feel happy. We meet our loved one, we feel happy. We meet our friend, we feel happy. Why? There is a chemical reaction in our brain using these four dose hormones. They do a chemical reaction, and that feeling, there is a pattern. There is a research that when people meet in VR, in metaverse, to their family and friends, they have similar chemical reaction. So this is a very big point, that even if you are meeting people in virtually, after some time you start believing them real. That may have consequences, but that's how it is. Research says that similar reaction happen. Yeah, a few more slides. I know everyone need to go to lunch. But yeah, these are interesting points. Virtual therapy is another aspect. You might be just watching Himalayas in the VR, and your doctor is operating on you. You don't even feel the pain. Without giving anesthesia, you can get your operation done. These things are happening. There are a number of therapies. People who has phobia of going in public, their phobia is getting resolved by these VR games, etc. And of course, different type of virtual identity I talked about. So this is the use case part. Let me quickly cover the concerning part. A lot of these devices are being built every day. If you see the list, this is all XR devices. Every day, new devices coming in market. And if we talk about other devices like mobile phone, etc., they are used. If we talked about what I talked about, metaverse and all, they all are really carbon positive infrastructure. Rajin will be covering how to calculate carbon intensity and all. All these infrastructure like blockchain, cloud XR. I am really talking about very high speed internet, 5G, 6G, where Gbps speed will be there. And I can really render things on cloud, and these devices will just become a monitor for these play. So there is a huge data transfer. Of course, a lot of infrastructure will be there. A lot of consideration need to be done while building such solution. So we need to balance the game. Other concerning part is these devices are being built, adoption is happening, but some people may feel left out. They may not still have access to these devices. They may not still have access to 5G. Today 4G is there, but in 4G also, even in this office, I'm not getting good signal. So even at 4G, I'm getting good signal. So even we build these use cases, we need to have both the side. We need to build solutions such a way that it can cater the mass audience. These are not mature enough. Still, there are challenges. User interface, etc., need to evolve. So it will take some time to really get there. In future, I talked about multiple identity, and there are privacy risk. If someone can hack website today, they can. If they hack metaverse, it will be more dangerous. Someone can act on my behalf, can come to office and do anything they want, because their virtual avatar is allowed to enter to office and they can do things. So think about its side effect. Your videos are floating in social media and you were actually not there. You don't those videos, and think about those things. And then media trials. Social media trial happened, and by the time people come to know the truth, your damage is happened, image damage. You might have seen this recently on Facebook. Someone filed a case on Facebook about sexual harassment case. Yeah. A lady filed in a metaverse because someone and now then Facebook has to implement a new feature in metaverse that they created a cylindrical safe distance. No avatar can come beyond that. So this is how these are the evolution I am talking. These things need to happen when we start using them. And in future, differentiating between real and fake will be different. So we need to think about it, how these things will survive. Other aspect of this is how it can influence really our decision. So we need attention from government, regulation, everyone need to come together and define solution. The last concerning part is even bigger. Those I just talked about. There is a research on Forbes article, legal heroin. VR is a legal heroin. So I talked some part of that article. Just read about it. When addiction happens, there is a chemical reaction in brain that causes that addiction. Today's games are being built and their testing happen with those reactions. If those reactions are happening in our brain, then only that game test stage is passed. Otherwise, they produce more level in it. Eventually, we get addicted to those games. That's how these are designed. So we need to be really careful when these things are being built. What is causing addiction? What is not? That's also sustainability aspect, how it can really impact. In these games, we may be kings or queens. We own a lot of things, but when we come out of the real world, we may be nothing. So we don't want to come out. So there is a lot of psychological disorder may be happening with these technology. We need to be really careful when we implement such thing. I talked about metadata and the connection. Now, if something goes wrong, you can think it's an information explode. I am accessing data in your brain directly. Now, what I can do really, because it can really go any level. And socio-political influence, we have seen everyone is talking about elections and all, but think about if I can program these things, your brain to think the way I want, then it can really impact heavily. What are the legal options? Probably not enough today. There is no police. There are different rules in those world. If I talk about metaverse world or gaming world, killing someone is okay. In the real world, of course not. So if we train someone on metaverse, a completely different environment, and we can brainwash the people, and they can follow their metaverse rule, what they have. No one is defining those rules today. So that's why it is important from sustainability perspective to come everything together. We need to create awareness about this, these techs, how future is going. We need to have more trainings, probably co-create solutions across companies, just like this foundation we have on one aspect, but we need more such foundations who can really cross collaborate and build solutions for this. By the way, note, if someone can easily say, I will not use this, that's not an option. You have to use it. Everyone will be using your family, friends, everyone will be using. Today, WhatsApp is becoming a common media of communication. Even bank notifications are coming on WhatsApp. Who can say I can't use WhatsApp? So that's the challenge. So that's how it is being monopolized. So yeah, that's all it is.
We do have a question for you from Sushmita. She says like VR AR has outstanding impact in healthcare and similar products, but it produces tremendous amount of energy to detect the eye and hand movements and training the AI models. Is XR imperative in fields like entertainment, given that lives are not involved in it?
Then, as I talked about, the session was more about awareness. What are the real impact on sustainability, that is still unknown. When we say which one is having which is the better option, that's the only game we need to play. None of the option is without carbon. Carbon, we are producing carbon with everything what we are doing. I'm doing this session, I'm also consuming carbon. So not producing carbon is not an option. But what is the better option? That's only we need to think. Maybe in certain cases of healthcare, running a bigger infrastructure, building a big hospital at different places of the world may be very difficult. I can have a teleconsultation, can really consult a lot of people. And I can touch the person from remotely and all those things. I can see the person 3D avatar. I can see rather than a 2D X-ray, I can really go inside it and 3D scan the body and can go inside and see more detailed problems. So maybe those solutions are better. Yes, graphics wise, they are costly today, but we hope that by the time evolution will happen, it will evolve, the infrastructure will evolve. The things which were not possible few years ago, 10 years ago, today they are possible. So yeah.
I do have a question of mine. I understand that in today's current world, it is not at all possible not to emit carbon emissions. But while you're trying to solve one sector of the problem, like trying to cut down on travel using extended reality, it's a very good approach. The amount of data that you're putting in the data centers, which actually contribute to much more carbon emissions, that's what you're actually trying to solve. So how does the extended reality community cater to, or like what is the thought about to reduce the carbon emissions, that the amount of data that you're putting out into the data centers and the emissions that are getting emitted there? How do you plan to mitigate this?
That's why when I talked about it reduces the travel, I given a disclaimer that it's a subjective thing. It reduces the travel. So it may reduce the fuel I will consume from when I come from my home to this office. It can do that. It could have saved, if I would have joined via Zoom, it could have saved that. But the kind of infrastructure, if I use for that, how much is the actual cost of producing that infrastructure? Like today is still 4G is still, we have some towers in infrastructure. There is always power consumption. 5G is coming, 6G is coming. That will even need more power. The more the signal we have, more speed of internet we have, it comes at cost. Every single bit is transferred at a cost. Yes, that's a challenge. It's just a balancing out game. So that's where we as a technologist come together and see what makes sense. It's not that everywhere we fit all the solutions. Everywhere 3D is needed and have a projector and stuff like that. Maybe we may not need everywhere.
Thank you, people. The board is up for one more question. Any more questions or?
Okay, thanks everyone.
Thank you. Thank you. You have shown us a different kind of reality. Not sure if it's extended or like a realistic thing.
That's what every XR person do.
Yeah, diversity you are saying, right? As a negative point that not everybody is covered, but it's also very, very good positive point. Lots of people are talking about it. That I really want to be, let's say there is a person who is in real life in a man's body, right? They're talking a lot that I really want to be in a woman's body, and I like that more. And in metaverse, they are able to do that very easily. So those are also inclusivity factors. I mean,
they don't realize the pain of being in that body.
There are not. This is not right. No, it depends.
What's the point then?
It depends on individual actually.
Yeah.
Some people like that aspect. Some people even don't like themselves seen as a different people, different person. So there are both sides of world. So that is why even avatar is being whether we should have avatar in metaverse or the photorealistic avatar. Which one we should choose? That's also a question. Some people say, no, I want to look like a Salman Khan. And some say, no, Salman. Same.
It will remain a pretty big question to answer. I don't know, since we're talking about Hollywood, I don't know how many of you have seen the movie Real Player One.
Yeah.
Yep. Ready Player One.
Precisely what can happen. And if you see that,
Ready Player One.
and you can bet Spielberg only can make it. So you can see metaverse, what can happen in metaverse. This whole kind of metaverse. So you can be any avatar. Edge is a lady in the movie, in the real world, but then she's something else. Good, bad, ugly, everything is there.
And we see social media today. We see everyone is happy on social media. Looks like everyone is going at different places, going traveling, and everyone is going this snap, that snap. Actually, that you are at home, you see, only I am the person who is sitting at home. See, this is the impact. We are already some kind of metaverse. So that's the impact we are talking, how it will really change the.
One question. During the presentation,
Can you be a little louder?
That
Excuse me.
when buy the property, they can go there and have parties. But
in the end, like how they can survive. Like the food is the main element. Like as you said, when a mother meets his daughter, the dopamine is released, the same chemical reaction. But how is this process similar to the food? Like if someone consume food in metaverse, how it will be similar in physical? That's
good point. Rajin, we have received a request from one of the food maker.
Okay.
That how we will sell food in metaverse. That's a very good point. So probably there is no solution yet. Probably how it will be, you will receive food at your home. Okay, everyone will eat. So you will have a good infrastructure of supply probably. For example, if I talk about Domino's, for example, I go and meet at some place and virtually, and then we order pizza. Now pizza will be ordered automatically at your home. You will receive the pizza. Once you receive, then you join that pizza. That's how maximum it was.
She has to watch the movie Ready Player One. That's what happens. Only break is for food and everything. And the rest they're on the virtual world.
And there is another aspect. 2 years ago, we talked about one restaurant in New York, and they were talking about AR, VR as a food testing. Like, how would you test a food? How the same food look like when you are testing at beach or at some other place? So you wear a virtual device and your environment is changed. After 10-20 minutes, you will feel like you are at that place. Now food is given to you and you eat. Now you will give feedback that. Then there are, as per that research, there are really food test is attached to your context, your mood. So they were making a restaurant that will change your mood first and then give you food.
It also depends on the taste, right? Even if how much you change the mood, if the taste is horrible, it doesn't make any difference, right?
It
Depends.
It also depends on your level of hunger.
Yeah, I mean, if it is average, right, it may be bad for somebody when they're not in mood.
We are delaying this more so that you like the food.
But for all the attendees here, Kuldeep is in this office until 6 o'clock today, so you can discuss about this extended reality on food, makeup, whatever you want. You can talk to him. It's lunchtime. I see people are like really hungry. There's like very good lunch out there. Unfortunately, we have to reduce the lunchtime by 15 minutes because we have a very important session coming up on software carbon testing calculation, where Razan and Srinivas and Raghunathan from Microsoft. So please head over to the cafeteria. And sorry, Garma, to go.
But we are starting in a minute. So if anybody is away from the desk, please come to your desks.
Do we have the main speaker here? Do we have Srini? You there?
Hey, Srini.
Can you hear me?
Yes, loud and clear, sir.
So our next speakers are Srinivasan and Razan. Srinivasan is a program manager in Microsoft and Razan is a lead consultant. And they are both presenting the talk on calculating software carbon intensity.
Thank you everyone for joining this. First of all, disclaimer, me and Srini are like, we haven't even done a guidance for this due to time constraint, but yeah, we'll try our best. And the format that we're trying to do is kind of panelist kind of a format or a journalist kind of a discussion kind of format in this talk. So what we'll do is I'll try to ask few questions to Srini and probably he being an expert of software carbon intensity, he will try to enlighten us more about those things. Yeah, on a very high level about me and Srini, we'll do that and then probably we'll start the talk. I'm working in Thoughtworks as a program manager into a program called as Innovation Lab. And then we're working on certain cutting edge technologies, etc. I'm coming from a developer background, and very recently I've started doing program/project management for this few things. Yeah, over to you, Srini, if you want to high level introduce yourself.
Sure. Thanks, Razin. Srini here. I've been with Microsoft for close to 6 years now. I also come from a dev background. Currently, I work, apart from my day job, I contribute to whatever extent possible on the Green Software Foundation initiatives, specifically the specifications that helps calculate the software carbon intensity, which we will talk about in this meeting. And I think since most of you also are from dev background, we can make it interactive and talk about the scenarios you have as well. So thanks for the opportunity.
Cool. Let's start with the first question, Srini. Everybody's talking, whenever they're talking about software carbon intensity calculation, right? The first question is, can software even emit the carbon? Is it a hardware thing or a software thing? Because before hearing this about this summit or this foundation, right, Green Software Foundation, I had never thought in that direction that even software can emit carbon. I was always thinking that it's a hardware thing. So what do you feel about it? Right? Is it a hardware thing or a software thing? Or
thanks for that question, Razin. And I'll share my thoughts. Feel free to add on top of it as well. So by and large, we all think of hardware being CPUs, servers, racks, memory, all those units. And there is a carbon emission associated for the manufacturing cost, right? Which we call embodied emissions, right? That is what typically comes to our mind. But assume you put that in a server, you are running software on that server. And even if you don't run, there is the idle machine also draws electricity to keep it operational. And whether it is Azure or AWS or on-prem or GCP or whatever it is, all these clusters of servers are sitting there and running idle. And even when they are running idle, it consumes carbon. The piece that we are trying to decipher is when you load software, your web applications, mobile apps, APIs, batch jobs, ML jobs, when they run on it, there is additional compute, additional storage, additional networking that happens between either the backbone and the internet, or to make the software run. And for doing that computational processing, it draws more electricity into the specific servers or memory. And like earlier we had a conversation that Sriram was talking about, it's all about the carbon emission associated with those pieces of software running on the hardware. Maybe it's just a hardware thing, but if you don't have software running on top of it, it probably will emit lesser carbon emission. So what we are trying to do as part of GSF is to quantify and qualify the carbon emission associated with this software.
So essentially, it is like if you are running a server or laptop idle, then there is a different kind of electricity being used versus you're running a software, and we're trying to calculate the difference between that.
Yes, that's correct.
Nice, Srini. Srini, one more question on top of it, right? When we say that when we are running a software, right, and then we are trying to calculate a software, but software is not always independent, right? There are lots of things which are coming into the software. Let's say while developing a software, right, most of the time now in modern days, I'm not writing everything on my own. I'm probably using some of the dependent libraries, etc. And probably I'm also deploying my software. I'm not directly deploying to the VMs, etc. I'm deploying onto the another softwares like Kubernetes, etc. So how do I calculate those things? I mean, does it matter that if I'm on Kubernetes or not, or if I'm using XYZ dependent libraries or not? How does it matter on that?
Yeah, thanks. Great question, Razin. So, and that brings us to this theme called software boundaries, right? Now, how do you calculate? Assuming you, like we take the same example of web applications or SaaS software, or the example that you took was very good. Today, everyone is using Kubernetes for deploying their applications.
we have to define in the GSF context, or in the software carbon intensity context, what we call as software boundaries. And what do we mean by that? When you say software boundaries, what are the components that are involved, right from the NIC cable that brings the data over to the software or brings the data to the last mile client device, to the Intel 7th generation or 8th generation or 11th generation processor that is running, to the RAM, to the Redis cache. Every component has to be identified for the web application or the API that you're running, and that you put it under this umbrella called software boundaries. This is probably the most important task that you will have to look at it very carefully when you try to calculate carbon intensity for your software applications, because there is a possibility that you could you could over engineer this, or you could miss out certain boundaries. So like we like if you take for example applications like Kubernetes, like these are built on microservices architecture typically, right? And there was a very good conversation on microservices architecture early in the day, and thanks Sriram for sharing those insights. It was very nice. But essentially what you have to realize that when you say you're taking up a software boundary and you're saying you're using a server in the cloud, that cloud is not serving just your software, right? It is in a microservices architecture, you densely pack such that the CPU utilization is as high as possible. So when you say you are using a server, you have to amortize the software boundary such that if the server is there for 4 years and you are running your application for 2 years, what is the software boundary for those 2 years? And that's where the formula of carbon intensity comes into play. So if you look at the GitHub software boundaries section in the SCI specification, a whole bunch of software boundary components have been identified. And needless to say, we need your help to identify more such boundaries. Whatever we have identified is we have identified in the last 1 year, but I'm pretty sure with the different type of workloads that are coming up, new technologies coming up, quantum coming up, AI coming up, there would be more additions to these boundaries. So I guess it's an opportunity to kind of go ahead and redefine the boundaries in the specifications. But in an essence, going back to your question, Riazin, the boundary definition is an important aspect around calculation of software carbon intensity.
Yeah, can I interpret as I want to calculate a software carbon intensity, and now there are multiple things that I am doing in my software, right? I need to find out, or I need to figure out one thing for which I will be calculating the carbon intensity. Can that be called a software boundaries? Like let's say I want to calculate a carbon intensity of a storage that I'm using versus the development laptop I'm using. Would that be considered as a software boundary, or is it something else?
Can you please repeat that question?
Like my developer machine, is it a software boundary?
Yes, it is. Yes, it is. Yes, it is. Because if you are, if you're running a WPF application, or if you're running a Windows Forms application, I don't know who does that today, but if you're running a Windows Forms application connecting to an API, let's take a very simple 3-tier architecture. Let's go with that. Let's take you're deploying a client-server application with an API sitting in the cloud and the database sitting in on-premise. Now, your software boundary will include the processing power that your client device needs when that Windows Forms application opens up, the CPU, the memory, the local storage, even the temp table that is there on your laptop even, plus the networking call that it makes to the API to bring back, say, for example, you do a get employees API call. There is data transferring, data in, data out, coming from the API. And then the API in turn goes back and it does a IO read into the SQL Server database or MongoDB or whatever it is. So these 3 components are high-level software boundaries, but then there are nuances, right? What's a carbon emission associated with the data transferring over the wire? And that's where I'm just extrapolating it this way. That's where most of the things that we try to do in optimizing emissions for software is directly related to what an architect would do to make an application more performant, add caching, reduce the payload, make your queries more performant, etc., etc. But yes, to answer your question, anything and everything that helps the software run will come as part of the software boundaries. And just for people to get context, I am trying to send a message in the chat where I have listed down what we have identified so far as software boundary components.
Anybody has any question on software boundaries or? Yeah. Okay, I have one small one, Srini, before we move forward on a software boundary itself. Let's say I want to calculate a carbon intensity of my software. Let's take an example of WPF. Everybody understand WPF here? What is WPF? No. Desktop applications. I mean, before a web world, there used to be a desktop application, right? If you develop a desktop application on .NET, the latest framework is called as WPF. But in your mind, consider it as a desktop application, not a web application. You're not opening something on a browser. So let's say I'm developing a desktop application and I want to calculate a carbon intensity for that. So one thing we talked about that my machine versus the software's identity, software's carbon intensity. But there is an intermediate layer also, right? Which is, let's say if I'm developing a software into Visual Studio Code or Visual Studio Code or IntelliJ for a Java developer, like my developer development tools. Does those also should be considered as part of a boundary, or those are two different boundaries to be calculated? Does IntelliJ have any impact on emission?
Great question. So the answer is more philosophical than technical. Let me tell you that. So in the school of thought for GSF, let's take, and I'm using another example other than Visual Studio, because that example is close to my heart. All of you must have used Log4j, right? Or any other open source framework, maybe Log4net if people are more on the .NET framework. So it's a common framework. You integrate it into your WPF or web application for logging and telemetry. Now, the question arises whether you should include the carbon emission associated with running Log4j in your software, or you say, no, it's somebody else's problem. I don't care. The same thing is with Visual Studio or IntelliJ. At GSF, at this point, we have taken a stand. We will be more ruthless. We will include it, because unless we start very stringently, we will not be, because there will be so many nuances that we will not be able to account for. What if you are not using Log4j efficiently? What if you are making a call to Log4j just, Windows form.load, Log4j form is loading, Log4j form is ending, or form is exiting? What if it's not efficient? So ultimately, the way you use your open source libraries also contribute to the software emission. So going back to your question, yes, if you have 20 developers all opening Visual Studio or IntelliJ for building a software, that can be done by 10 people. That can be done by 10 people. Philosophically, you are using less carbon emission. I'm not saying you should do that, but that's how the calculation is today.
So sorry, Srini, just to pause you a minute. Your voice is little unstable. It's breaking a bit.
Is it better now? Sorry, I'm so sorry about it.
This is good. Thank
That's
you.
way better. Thanks.
Cool. So if there are no more questions on software boundary, we can move forward. Any other questions on software boundary? No. Okay. Srini, the next.
Razi, sorry. I just wanted to hear some thoughts on other scenarios that we may be missing, and more than happy to take them back into the building of the specification. If there are any scenarios either on the bridge or
I have a very basic question. Very basic question.
Yeah.
Today, and everything is on internet. So until you are not connected to the internet, you literally can't derive the statistics of calculating a software carbon intensity. You wouldn't know where the user is from. You wouldn't know what kind of electricity that the region from it that user is from generated. So is there a way that if I'm disconnected from the internet, can I still calculate the SCI for the applications that you use on my systems?
Yes. So let me rephrase your question so that I understand. So it's more about a scenario where you have everything running offline, and you still will be you want to find out whether your application
Yes.
is okay. Okay. The simple answer is there are power and plug meters that you can use. Very simple, like you connect a watt meter to your laptop and run your application, and you have to do some proportional calculations, and I can share the link to the calculations we have done for an application hosted in Azure. So we were going back and forth about how to calculate the intensity, assuming this entire web application is deployed onto the local client laptop. And the conclusion that we came was use the same formula, which is a combination of CPU, memory, GPU, that this application will use while running on the laptop, and also include the what do you call intensity associated with the display, etc. So the same formula that applies for a server can be used in your laptop. The software boundaries will be redefined. As you said, there won't be any networking components, but you are still using compute resources. You're still using storage. You're still having monitoring on your laptops. So yes, you can calculate that.
But how do I define the source of energy in the SCF formula? That is like one parameter wherein we even come to the parameters of a power. We have not even. Okay, then fine. That's where the boundary is part. Yeah.
I got another question. Yeah. Usually, when you're talking about software boundaries, you talk about for a running software on a system. Let me take just an example of an operating system. On a Mac or on a Windows laptop, whenever you go and upgrade an operating system, it's like a 2 or 3 GB update, maybe a 12 GB update also coming in. So that kind of the time it takes to upgrade and everything. Are you factoring that into this calculation of software boundary?
It's again a software boundary. I mean, in my mind, right, for somebody who is OS provider, right, for them, one of the boundaries, what are they emitting while doing an updates? Nowadays, right, IoT devices becoming very, very famous. Over the updates are also very, very famous, and this size is getting reduced day by day. The smaller OSs are coming, but that doesn't mean that this is not something that need to be factored. So this is one of the boundary for them. Who is the OS creator? When I am updating my OS or my software, how much I will be emitting, and that they need to calculate and formulate into their probably yearly calculation or whatsoever. Srini, you wanna add anything?
No, that's perfect. That's perfect, and that's a great call out. I think when we get into scenarios where we will have to calculate SCI for OS, and how OS developers start building these upgrade patch software, and how it is going to impact your client devices. I think this is a very, very good point to take into consideration.
There's one more question.
Looks like the software boundary is like very interesting. We have one more question from one of our members.
Not really sure if it is in the realm of software boundary, but then while calculating the carbon footprint, do we also account for the number of users of that software?
That's the next question I also have. We'll come to that. But yeah, before we go there, any other question on boundaries?
Just the boundaries.
2 questions shut down, then let's move.
Boundary is one interesting area, so definitely.
I have the exact same next question to Srini. Srini, like when we decided software boundary, right? Now let's say my software may be dependent on so many things, right? Let's say I have enabled auto scaling. Today I'm working with a scale of 1 or 2, but the more number of users increase, or the more number of requests increase, my boundaries keep changing, right? The number of machines keep changing, and there can be many factors like this. So can you explain what are the different factors which can impact this, and what are the things we should take care? And just a disclaimer, it is called as R in SCI, so just remember this R.
Yeah, sure. So the R factor in SCI is precisely included for taking care of the scaling. And R in SCI is called a functional unit. A functional unit, why a functional unit? It's more around, and there are multiple functional unit parameters that we have identified. I think a couple of them you mentioned earlier. One is number of users, number of API calls, number of machines that are making this call. So there, and number of devices, data volume, for batch jobs that do ETL processing. If you say this is the carbon intensity for 10 GB of data, obviously for 20 GB or 200 GB or 1 terabyte, it will be different. So the functional unit there is the data volume. So in essence, the functional unit is the scaling factor, and typically when we think about SCI, let's think about it as a relative score, not an absolute value. That is the most important thing that we have to keep it into account. So if you say you're building a Dynamics application or a SaaS software, and you say this is the software carbon intensity, without the scaling factor that has to be defined by the person who's building the software, the SCI score has no relevance. So the scaling factor will change. Like for example, earlier I said the batch job depends. If it's a ETL process, it's a data volume. In the case studies that we are doing today, web applications, mostly how do you commit to customers that our web application is performant? We do load test, stress test. I think there's one more test also. In all those tests, what do we test for? We test that if it's an e-commerce application, there is a Selenium or a JMeter test that loads users every 5 seconds or 10 seconds, and then there is a peak user and then the concurrent user. So in this case, the way we defined R is a combination of what is the SCI value of the e-commerce application for 5,000 users and 10% of it, 500 concurrent users. The reasoning behind, we knew that if the scaling factor changes, the software boundary also changes, or it doesn't change. We don't know. If someone says, no, I want 5,000 users, but the hardware has to remain the same. I can't scale up the hardware. I can't do auto scale. I can't do scale up. Whatever the reason be, when we go and publish SCI score in our, into our external facing customers, we'll have to be very sure what is the basis. And that's where R comes to the picture.
Does that answer? Any other question on R?
I had one or two on software boundary. We'll come back to it in the last maybe.
Okay. Yeah. So quick question, Srini, right? There are two questions actually. One is we are saying that R is a scaling. What if there is no scaling? Will that be R, or there will be a static R for that?
I'm not completely sure of scenarios where there will not be any R, but we can discuss. Today we are going with the premise that there will be R everywhere in all the scenarios. But if there are scenarios, we would love to know. We would love to know, because we are going with that assumption today.
Yeah. So scaling means what are the number of things that we're using, right? So auto scaling and scaling are two different things. So if we do not get confused with that, then whatever manual scale that we start with, that is our R. That's our scaling.
There is one important, I think, the nuance, and this may prompt people to think about questions for R. When we were doing this case study for calculating SCI for web application, we chose R as number of users, which means, as I said earlier, 5,000 users, 500 users. But then the earlier scenario you brought up, Visual Studio and IntelliJ. So while we can say this is a SCI for this application in the production environment, pre-production environment, UAT, etc., 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 the R value doesn't apply to each of these environments. Obviously, in UAT, you are talking about a subset of users. Say you may have only 20 users doing your UAT, but in production, you may have 5,000 users. And in dev, you will have 200 developers. So if the important piece in calculating SCI is if you don't have uniform R across the different stages of your life cycle, you cannot use that. You cannot use SCI there. in this case, the step we took, the direction we took, we said the R we chose is only for production environments. We discounted calculating SCI for all the lower environments in the first version of SCI. We may include it in future, but the R value has to be consistent across the different components you use in the software boundary. Else this whole formula will fall flat. I don't know whether that triggered any thoughts. Happy to hear.
It actually triggered a confusion.
Okay.
It should.
It should.
We just need one more round of explanation, because like you talked about many parameters there, many inputs there.
So let's say, I mean, if the confusion is that if the software boundary is different, then how can R be the same, right? That could be the confusion. So
that is one of them.
So let's take an example of number of users, right? Let's say number of users are being taken as R. So what is the impact of a number of users on a storage? So you can think of it in a way that, okay, if the number of users are increasing, that means they're adding more file, that means they're using more storage. So that means the same R is applied for a storage. Now, same R applies for a network. What is the impact of number of users when I need to calculate software carbon intensity for a network? My software boundary is a network. So number of users are more, probably it will increase. So R may have different impact on different software boundary, but the important factor here is R is same across the boundaries. So impact may be different. Right?
That's correct. And yes, and to make things more simpler now, what you can do if you want to calculate SCI across all the environments, have different R's for each of your environments, because in the lower environment, like dev and test, you may have 20 developers, and you will have to calculate the carbon intensity of them building the software, which is a Visual Studio, IntelliJ, whatever you're saying. There, the software boundaries may be different. When you move into test environment, you may have different R. Calculate them separately, add them up. That's all.
I have a question. You mentioned about, let's say, R being number of users and for a single environment. Let's say it's a production environment. And you mentioned that as an example, which you took 5,000 as the number of users. But when you talk about the number of users, there's also a part of concurrency, or the concurrent number of users coming in.
Yes.
So in a same environment, the number of concurrent users would vary over a time period. Plus, if you talk about the overall number of users accessing, that would also vary over a period of time. So does it mean that if you take into consideration a broader time zone, R or this SCI formula would fail there? You need to use something different, because your point in time, yes, you can have it, but R would change in terms of you could say a 1 month or a 2 month or that kind of a time frame.
No, R wouldn't change that. You would factor that time zone in the R. That my number of users for continuous parallel 5 months, my average number of users for 5 months. You will, if there is anything which is factoring your scalability, you will factor that things into the R also. That is your R.
Okay.
Srini, yeah, if you want.
Perfect.
So any other questions on R?
The factor, that means you'll add that as another.
Yeah, as a definition of R, you will say that, okay,
in 5 months.
In 5 months, my number of users.
So basically, you'll have to first calculate or derive another formula for calculating R.
No, you need to be knowing what are my scalability factors. What is it that will impact my software? And you will anyway do that for your probably cloud association to decide how much of the cloud I want to buy, or how much of the things I want to keep ready for the cloud. For those things, you will anyway calculate that. You just need to factor the same thing, same scalability factor into for the carbon emission. Cool. We can move next. Okay, so we'll speak. We'll go to the next question. Okay, we understood the functional unit, right? Let's say if my software is running and I need to calculate the carbon intensity, we are continuously talking about I need to calculate the carbon intensity. But what should I calculate actually? How do I calculate the carbon intensity of my laptop? Is it an electricity, or what should I be calculating?
Yeah. So so there are a couple of ways to do that. One, I think earlier we were speaking about client device running an offline application. So the easiest way to calculate. So what is E? Basically, in the SCI formula, maybe we can flash the formula later, Rajan.
Yeah.
But in the overall formula, it is E is energy expended by the software multiplied times I, which is the carbon intensity of the region where the software is running, plus M, which is the embodied emission, right? And then divided by the functional unit of R. Now let's keep I and M. I think we will come to that. From the E concept, it's basically the power that is drawn from the electricity grid, whether it is an on-premise machine or a data center, by the server or the rack, to which is additionally needed over the idle power that is consumed by the server. So essentially, it's the unit. If you think about it, it's watts. The easiest way, most correct way, is if you can take a watt meter, plug it into your machine when the software is running, calculate it. But that's not always possible. So what we have done is we have related the electricity additionally needed to run the software with the cooling power needed for all the software components in the software boundary. So this is called, going back to, I think this must be 11th standard or 12th standard. I don't remember. I mean, it's been quite some time. Physics, 11th standard, 12th standard physics, which is thermal design power, TDP. So every hardware that you see in your machine, it's a motherboard, CPU, RAM, has a specification called TDP in watts. So what we assumed that by default, if you take a 32 GB memory, if you open it from, plug it out from your desktop, it will have, I think, 20 or 28 watts for DDR4 or DDR3, depends. And same way for any Intel 7th generation, 11th generation processor. We have used that, and there is something called thermal design power coefficient, which is the amount of power drawn by the software while running on that particular component. So the E is, in essence, we have done it's directly proportional to the amount of cooling needed by the server when after it draws the requisite amount of power from the grid or power supply or whatever. And the way we have calculated E is very simple. I think I go back to the example I shared earlier, is through a load test. So we have done load test, and there may be multiple approaches, and that's where we need more, help from the community. We have taken approach A by running this application in a typical load test scenario and saying, if the application is running in AWS data center or GCP data center, it is consuming 80% utilization or 70% utilization for a 1 hour period. So for that utilization, we calculate what we call the TDP coefficient. And I'll share the links to that study in this chat. Hopefully you should be able to do that. And we have used this correlation to come up with E value, the energy value used by the software for running that, for running in that particular software boundary.
So I think now I asked a question to Srini. Now the question to the audience, right? Srini has spoken about 1 or 2 ways. Now we're not talking about calculating carbon. You understood that, right? When we say about E, we are calculating that how much of the electricity that a software is consuming. Srini has given 1 or 2 ways. Is there anything else you can think of? Is there any other way to calculate the electricity that my hardware is consuming if I run a software versus if I don't run? What is the easiest way to calculate the electricity? I think those are the only 2 ways. I was thinking we'll get something and we'll add it into the GSF specification. But I think
I'm sure people will come up with more ways, Rajan. It's just a matter of going back and trying this out. I think the challenge that we all have is when we try this formula and we come up with a number today, there's no way to say whether we are right or wrong. That's the state we are today. And that state should change if we get more case studies, if we get more examples, try out formula. Obviously, we haven't invented something like what any Ohm's law or Moore's law or whatever, I'm sure we are at a far immature maturity level today. So this has to mature, right? And that's where we need help. But the approach we have taken is simply to look at the cooling effect of these components and correlate and make it directly proportionate to the energy consumed by these software when running this on the specific hardware. That's the approach we have taken so far.
But there is one suggestion from Naval. His approach is like execution time, execution per unit into time. So if you multiply these two parameters, then you would get the energy consumed, or like you can calculate the electricity consumed.
Yeah, so yeah, one of the way that she was explaining, right? The finding out the execution time and then figuring it out for that execution on an ideal state, what your machine is taking. Like for, let's say, for a base execution time, how much your machine is taking, you multiply execution time by that. And to calculate the base execution, whatever hardware that you're using, right? Those hardware provider now, at least in this current world, are supposed to give you that base execution time. Like let's say Srini was giving an example of Intel versus the RAM. They are giving you that if you run for 1 minute, 1 minute, 1 GB, if you run this much electricity that this RAM will consume. Those examples are those things are available, and you need to just add up all those things and you will get the E. And
so you basically are using the formula of P is equal to E into T.
Yeah,
that is when you're talking about a server that is not connected to the system or the network.
Correct.
Otherwise, the network is also consuming energy, and that's not being factored in.
No, you'll have to actually calculate the amount of energy consumed by the network also.
By the network,
Exactly.
that's a different software.
Then you'll have to accumulate it. It's a summation.
Then you have to add the summation.
In fact, when mobile device come into picture, the equation will completely change.
Equation might not change, but the definition of the R, E, E's, all those will change. E will change. E will be like how much of the battery it is consuming, and then for that battery, how much of the charge it needed. Both the things will be factored into the E.
So basically, to put it in a very simple way, you'll have to like literally calculate the E component, R component for each and every component in the entire system. If you're developing a mobile application, what is the amount of current your laptop consumed to write the code? And when you deploy it on your platform Android, how much battery it is consuming? How much did the Play Store at the first place is providing your data amount consumed at the data center? So this entire is a chain of events, and when you sum it up, you'll get the final number.
Yeah, just on a vocabulary side, you have to calculate for each component for each software boundary.
So hardware factor also chip into.
Yeah, it does. It does. I mean, SCI calculation, it is not only at this, when we say software carbon intensity, right? I mean, you cannot run a software without electricity, without hardware.
No, so what I mean over here is so my machine configuration is different from your machine configuration. Right? So that factor is also being counted in.
When you calculate a software carbon intensity for your software, your machine doesn't come into the picture. Then you calculate for a different software boundary that is for your machine. Then you calculate for a different software boundary for Krishna's machine.
Okay, so the software boundary is what changes over
yes.
There, right?
So then on top of that, software. So when you calculate on your machine your software's boundary, then you need to minus your machine's base when it is idle. That is only giving about your software. And if I do the same thing on Krishna's machine, for the software, the number should come same.
Yes.
But again, you might ask one more question here, like how do I get the effectiveness? Like how do I determine this particular laptop or this particular mobile consume this amount of energy? That is called, you continue.
That we call.
I mean, I'll let him continue.
Yeah, I mean, that's a different boundary, right? You calculate first for your laptop and then for your software, and then you sum it up.
So when you brought up this boundary thing, in terms of calculating it for a laptop, what is the boundary of the boundary?
There is no boundary.
What is my question?
There is no boundary because...
I'll tell you the reason I asked that question is, see, there are emissions at the stage of scope 1, scope 2, scope 3. So what is the boundary where you'll define where you'll end that software boundary? Will you take it including the softwares required to manufacture your machine by the vendor? Will you take them into account also?
We do. That's what I
We'll
want.
come to that.
We'll come to that.
That is why I left that particular question.
We'll come to that.
So I think I'll try to answer that, Kunal. The approach that we are taking is we are trying to take as many components into inclusion because one, our ultimate aim is to reduce carbon emission, right? And if we add more from an optics perspective, it will show up more. So there are two schools of thought: consequential, attributional. The GHG protocol uses the concept of attributional, where they say, you know what, this open source library is owned by some Creative Commons license. Their carbon emission is their carbon emission. If I use that software, I don't add it up. That approach is good if we are in a steady state today. Today we are in a very immature state. So we want to grab that as well into the carbon intensity calculations just to inflate numbers, to make sure that we are conscious of the fact that we have to continuously. Today we are in a scenario where we don't even have SCI as NFR. Until we reach that stage, we should be conscious of whatever carbon emission is associated with the software that we are building. So it's more of whether it is right or wrong. I don't think that is the way we are doing. We are taking everything into account for now, which is non-hardware specific, and seeing if we can continuously reduce or iteratively reduce. Maybe at some point we will throw that open source library carbon emission associated with the open source away at some point. But today we don't have that flexibility to do that today.
There's some questions in the chat, Rizal, if you want to.
I'll ask it. It's like you can read it actually.
They're bigger ones.
There was one which was missed out also.
I mean, the one which was asked before, like I parked it for the last.
Okay.
Because that's again on carbon emissions. So this question is like, how do we factor total cost of ownership country-wise? Resource richness, environmental factors, technological maturity. Where is the cost of generating renewable resources? Example, Canada versus India. Then,
So yeah, let's go to that question. If there is nothing on E, then we can go to I.
Anything on E?
Anything on energy?
Okay, energy.
Nothing, right?
Yeah, one question on energy.
Yeah.
How do you factor in the energy or the pollution created by noise? How do you account for that? Because that is one missing factor which I've not seen anywhere right now. And that is noise pollution is one of the biggest factors which is being ignored for now.
But today we're not talking about the pollution, we're talking about the carbon emission.
Right. So but carbon emissions also increase and vary the atom. If I get into that level of details.
Yeah, I mean, at least I'll let Srini answer
to a chemistry.
Yeah, we'll have to convert it to
I need to go back also to the chemistry class. I'll go to Srini for that. Srini, does noise pollution has any impact on carbon emission?
Sorry, I do not much enough information. I don't know.
Nobody knows that we can answer anything. No, it doesn't have any impact.
I don't know whether there is a formula between decibel and watts. I'm just going crazy. Sorry, I don't know.
It shouldn't be. Those are two different kinds of pollutions. Okay, cool. We can go to the next question. The one which Krishna was reading, right? So Srini, the next question is, okay, we calculate the energy, but this energy, right? It can come from a different places also, right? Like something which is generated from solar versus something which is generated by coal, or probably different countries have different methodologies of generating energies. Like it is little different in India versus little different in Canada. So does it also have any impact in carbon emission?
Oh, absolutely. And that's a great question I saw in the chat. How do we factor total cost of ownership country-wise? So I, in the SCI formula, is regional carbon intensity, which is more around how the electricity grid in each of these countries is powered, whether they are powered by coal. Like I think you covered most of it: coal or renewable energy, fossil fuels, etc. So, and also I think you guys must be aware there is work done by Google also to shift workloads that are running within their GCP cloud to regions which are more carbon aware. Say, for example, it is running in Azure. I'm sorry, GCP won't run it. It's running a batch job and it runs for 4 hours, right? Rather than running it in West US, which has X carbon intensity, because that X is coming from standard standard APIs, and I'll come to that a little bit later. It could run that in West Europe, which is much more carbon efficient or renewable energy efficient. That's one approach. The second approach is you consciously shift the workload. So if you have a 4-hour workload, when instead of running it in the peak of the day in West US, California, when the sun, in the night or in the day, when that specific data center is powered less by renewable energy versus powered more by renewable energy, that's also an approach. So the I is meant to give users that flexibility in choosing the right region which is appropriate for their needs. Also, let us all bear in mind the entire world's data center regions are not always carbon efficient all the time, right? Because if you think about how data centers are powered, it also needs renewable energy. It also needs fossil fuels. So it's that mix that creates that difference in value of I. There are APIs. If you go and I think it's called What Time is one API, and then there are a couple of other APIs. It will show you a map of which area. So if you take the North America map, whether Michigan or California or South Carolina or Texas, which area is more carbon efficient, which area has less values of I than more, and you can choose. You can choose to run the workload wherever appropriate, or you can build intelligence into your application to dynamically shift the workloads to that specific region and shift it back to another region. That's what Google is doing.
Does it
Don't
answer?
know whether that.
Does it answer the question? I think yes. That's a thumbs up from Naval. Okay. Anything else on?
Yes, we have.
Yeah.
We have another question from Sushmita. Are we also calculating the data center emissions that our code is leading to? If we do, then the company, for example, AWS, is also calculating that and trying to offset it. That would mean the same energy is being offset twice, one at our end and one at the data center's end.
Okay, brilliant question. So as part of SCI specs, we have taken a stand. We will not include offsets. Offsets, if a particular data center cloud provider says my overall net emission, like all of us will say, right? My net emissions is 0 because I have offset. That is not included. You have to tell me what was your raw emission. You purchased carbon offsets because of which it came from 100 gram or 100 kilogram CO2 to 0. That doesn't matter to us as of now, because if you start doing offsets, you can always pay money to reduce your carbon, and carbon neutralization is not included as part of the SCI calculations.
Yeah, and if I have to add on top of what Srini said, right, very well explained by Srini. Like one few of the other things, right? When AWS says that I'm emitting this much carbon and I'm neutralizing it by doing XYZ, most of the time they say that what is it done by their core resources, not by something that is being done by running our softwares. And everybody, most of the cloud provider, I think, including Azure and AWS, are coming up with a page or an area, or you can say a dashboard, where you can see that now because of your software, how much carbon you are emitting inside an AWS. So you don't need to calculate lots of things. You will be getting your calculations, and AWS will not calculate that emission into their own calculations. So those are two different things. And if there is something of an overlap, it's an added advantage for an environment. Why not try to reduce it twice, or why not try to neutralize it twice? Although it doesn't get into the calculations of SCI, because neutralization is second. First, you need to know how much I'm emitting, and SCI is about how much I'm emitting.
So there is one factor which will I think get included in the SCI formula, which is called PUE, which is power utilization effectiveness. Right now it is not there. Basically, if you take a data center, irrespective of whether you run software or not, it is running. It is running such that all the power cables are connected to electricity, the air conditionings work, the cooling system work, the adiabatic cooling, all those things work. So PUE is the power ratio of electricity used by the data center that is powered by renewables. And that factor will tell whether that specific data center is, SCI friendly or not. Most of the time today, I see this is published in a public forum. I'm not confident that every data center region information is there, but I believe I saw some time back that every cloud provider is now being compelled to publish this information about their data centers. And we have not included this in the formula today because for the same reason, every data center doesn't publish every day. We don't have the official data set for this, but at some point this will be included as a factor into the calculation because that's how the energy efficiency of the data center can be brought into the SCI formula.
How do you calculate the PUE? What are the parameters you consider when you're calculating PUE?
The PUE?
Yeah.
Can I get back to you? I read that somewhere, but I'm sorry, I don't remember that right now.
I asked this question so that it would be an informative for the people. But we calculate the PUE like you capture the entire energy used by the data center and you divide it by the energy used by each and every component in the data center. So that will actually give you the PUE output.
Yeah. Thank you.
Any other questions? So we can move forward.
There is one question that I see on the chat from.
I'm good with the time.
Yeah. One question. Life cycle assessment of a software.
No, that's not a question.
Okay,
You're just drawing the parallel.
Thank you.
I think we're okay with the time.
Cool. So probably we can move to the next question. So we have spoken about the running software on a hardware and calculating anything on the hardware. But how about the manufacturing versus transport, etc.? Let's say my software boundary is I'm calculating the emission on probably my development laptop, but my development laptop would have manufactured at XYZ country, and from there it would have shipped. And while manufacturing, they would have used some carbon, right? Versus in some other country. Does that also factored in like the manufacturing of an hardware?
The manufacturing cost and the carbon emission associated with the manufacture is included in the M, which is the embodied emission. I don't think today we are including the logistics aspect of it. I believe, and that probably may be a reason where we are distinguished between scope 1, scope 2, and scope 3 emissions. I believe, and I need to check this again, but the M value today is more around the amount of carbon emitted during the creation and disposal of any component in that software boundary. Okay, and like I said earlier, let's take for example a Dell server. Typically if you go to some public data sets, you will get what are the embodied emissions associated with either a Skylake processor or Ice Lake processor, Broadwell processor. You pick that up. I mean, I'm just talking about the methodology we used while pulling in that M value. And you amortize it in the sense you use your in the scenario that we took up where we did load test for that 1 hour period. We assumed that for that 1 hour period, and we have made a lot of assumptions there, for that 1 hour period that software is exclusively running on that device, and we kind of have a calculation around what could be the potential lifetime of that server in either the data center or the on-premise machine. Divided by the amount of time in minutes or seconds your software runs on that, plus multiplied by the resource usage. So if it's a VM and it is a 16-core VM for the purpose on the bare metal, obviously if it's a VM, you will have only 2 cores associated with your software. So we have done all these calculations, and our embodied emissions, to answer your question, Razin, we have calculated only from a LCA, which is the manufacturing costs associated. The logistics piece is an interesting concept. Frankly, we haven't spent time on that.
Any other questions on?
We have one on the chat.
About the manufacturing, I wanted to ask. Do we calculate the embodied carbon emission of devices which are used to build or deploy the software, or also to the devices of the users who are using the various hardware of a running software? Do we only calculate the device like a cloud devices? Let's say it's a web application, right? Which will be running on the end users' machines. So do we only think about the cloud devices, or do we also think about the end user machines?
The first part of the answer is no. Right now, we have not included the embodied emissions of devices which are used to build or deploy the software, whether it is a DevOps agent or a Jira tool or a build server that is used to do your daily builds. At this point, we have not done that for the simple reason it is conflicting with our uniform expectation of R, right? So for that, we have not used it. But yes, the devices of the users who are using various hardware for like the same web application that you said, when we said it scales by the factor of R, 500 users. So we have included the carbon emissions associated with the embodied emissions of all the, assuming for all the 500 laptop devices. But then, while it is a formula, these things are given separately when we publish the report numbers, so people can. So there are only certain things you can do to reduce your SCI. If you have 500 users and all 500 users have to run it, you can't do much about reducing the carbon emission of those client devices. But you should be aware of the impact it creates. Where you can do tuning around energy efficiency, hardware efficiency, and carbon awareness that Kunal spoke about in the morning is on the server side of things.
Yeah, in one of the case study, when I was calculating, right, I completely skipped that part, like client's carbon emission, for the same reason what Shini was saying. Even if I calculate it, I don't have any control on changing those things. So that's why, like Shini is saying, right, most of the time, the more focus is on which is owned by us. Us means as a company who is trying to reduce the carbon.
Yeah, and those we can conveniently tune as well.
My question would be, when we were talking about, Shrini was mentioning about the emission caused by manufacturers, and that's included. So when we talk about that, is it expected that the manufacturers also mention whether they are, what kind of scoping they are doing from an emission perspective, whether they're covering a scope 1, 2, or 3, because that would also make a difference in our calculation logic. So is it expected from them that they somehow communicate that for the particular components to us?
Yeah, I mean, for each and every component, for example, let's take the example of a data center. Each and every component that you use there, the manufacturer actually specifies the amount of carbon emissions that particular component emits when put into usage.
What I'm saying is, it specifies, but does that the manufacturer specifying, let's say for RAM, let's say having 100 grams of emission. So with that 100 grams of emission, we consider from a scope 1 perspective, scope 2 or scope 3 from that manufacturer. Because it could be possible that the manufacturer is considering only a scope 1 emission when specifying that, whereas we are working towards a scope 3, the actual person who's purchasing it. So from that perspective, the calculations or the results, the final results would vastly vary.
Yeah, so I think the manufacturer actually considers all the scope 3 also. Everything. They ideally they are consuming, the amount of raw material they're procuring, the transportation, all the amount invested in
procuring everything to bring out one component, what are the total emissions that are incurred will actually goes into that component. Yeah, so ideally, people wanna target all the 3 scopes, but it would be great if they, when they write about the emission, right, they also write about which scopes they consider. It's all about the right messaging. Because some things are not possible. Today, Apple is giving you all the data, how much of the carbon it has emitted for Apple device to be manufactured. But they are at other place claiming that they don't have scope 3 data.
Right.
So
that's the reason I asked the question.
It's all about the communication, that when you see that when the Apple site, right, where they're saying this much was manufactured, this was the carbon emission while manufacturing device, they are also saying that these are the scopes we have considered. They are not, I mean, category they're not saying, but they have clearly written the scopes. Yes, they have clearly written the scopes.
I'd like to ask you one thing. We're just considering one side of the spectrum here. That's the manufacturing side. But if you see, there's another aspect to it, which is the end of life. So when a server is discarded, or let's say any software or a hardware component gets discarded or reaches, that disposal part, that also might emit, especially for a hardware perspective, that would emit emissions.
It's part of app. You should calculate that as a part of app. Right, Shri?
Yes, agree with you, Razin. The M value that we have defined is both for the creation and the disposal of the device.
Yeah, we basically rely on the manufacturer to give that information, and we do not have any control over it. So, correct. Say a calculation we give out is we assume that the information we get from the manufacturer is appropriate. Assumption.
Correct.
Yeah, we have to. Okay.
No, absolutely, it becomes a supply chain problem, right? You go and source from all these. You believe what you get, and then if you really want to get into nuances, Kunal, your question is spot on. While we get Dell laptops emission is 350 grams, what part of it is scope 1? What part of it is scope 2? What part of it is scope 3? Why should I include all these 3 in my software emissions? But I guess the challenge in all these is the availability of data.
Actually,
cool. So we can quickly calculate. I mean, why to tell the formula, right? Shri was saying that we'll tell the formula, but I was thinking why to tell the formula. We know now everything, right? That we're consuming electricity, energy or electricity. We know that electricity, how much carbon it is emitting based on the region. And we know what is the manufacturing emission, and we know we are calculating for each and every hour. So can somebody guess what could have been the formula to calculate SCI? One wild guess. Anybody? We know, and it is consuming energy. We know we're calculating for hour. For each individual hour, we are calculating SCI. We know it is electricity. We know the carbon emission per electricity for every electricity. We know the manufacturing emission. This is including, this is the final emission. So what would have been the formula? Quick guesses. People on the virtual side also can type in your formula sessions. Anybody? Wild guess, quickly. Wanna try?
So I think E and I would be multiplied, right, in part of like whatever is the final formula.
If I multiply E and I?
M, what I could not get is M per component or the
final
emission.
Final M.
Then probably add it. And unfortunately, I was not here when you discussed R, so I don't understand that.
R is a functional unit.
There's another
for which you are calculating this formula.
There's another reply on the chat from Yamini. It's I into E into R plus M.
I into R plus M, but we're calculating per I. I mean, we're calculating for I.
You asked for the wild guess.
Yeah.
You got it.
If this R is per unit, is this whole thing multiplied by R?
R is a functional unit for which we are calculating per component. Per component, yeah. So for R, we are calculating this carbon emission for R. Is it right? Any changes you?
So is E? Is E a function of R or not? Like, does E depend upon R?
No, we are calculating the whole carbon emission for R.
For R.
For R.
Divided by.
Divided by. Okay. Any other guesses? Any other changes? That looks good to me. That is good to you because you know the specifications. That looks good to me. That is the correct. Okay, yeah, so now we know SCI so much that we only calculated the formula. Everybody is up and ready to go in another session. Now you have lots of people who know about SCI and they can just contribute open source to SCI.
Please, more than happy.
Okay, so I think we know the formula, we understand everything, we have calculated the SCI. Srini, next question is, once I know my SCI, what next I should do?
We have somebody.
I had one question, may not fit in here, but we were talking about the offsets, and I understand that we're not considering them to at this point being the state we are in. Is there also a concept of offsetting because my application actually saves carbon from another use case?
No, I think the answer was not that offset we are not calculating. What we're saying is offset comes after this. Basically, first you should know how much carbon I'm emitting, then I should start trying to offset or do other things about it. This is about calculating.
Yeah, this is the emissions.
Emission calculation.
Right.
So SCI is all about software carbon emission calculations.
And it stops there, or do we continue talking about
Green Software Foundation continue talking about it.
It is like, how do we reduce the emissions?
So the next step for Green Software, the next project for Green Software Foundation would be how do I reduce it? How do I emit?
An offset would be one way.
One way. Else or
I just have one. I don't know how does it fit or not, or are we ignoring the background processes that might be running in every situation?
Like example.
I mean, if we were talking about a local system, are we ignoring the background processes that we have running?
We're not, because let's say if you're calculating the software intensity of my, for me, the software boundary is my software. First, I'm calculating with the machine without my software. That means that background processes are coming.
So, but like, is it in M?
No, background processes are not in M. So basically, while calculating the energy, right, you will have something called as baseline first. So baseline is your machine without your software with all the background processes, and then you calculate with all the background processes and everything, and then you do minus, so you get your software. But I mean, all that minus and all are for you. But if you talk about SCI, your idle machine, like without a software, is one software boundary. With your software is another software boundary.
So let's say if I have a machine which has an operating system and I'm using Chrome browser, which has a lot of background processes running, as an example, so I'll be doing multiple calculations to arrive at the final claim. If I have to do it, the machine, that's going to be plain machine without an OS. Second, I'll do it for the OS. If I don't have it directly, then I'll do the entire thing when the OS is installed, so that I can calculate for the entire thing and minus the machine. Then, if I install Chrome and run it, then what's the emission? I mean, it has to be that kind of a
So
to arrive at the final one.
I can try answering that. Okay. So like we just said at the bottom, I'm sorry, beginning of the session, SCI is not an absolute value. It is a rate. So at the initial, like the same example you took on day 0, your value was 2000. And then you did some tuning. You added caching, you removed temp DBs, you improved the performance of your queries, etc., on the database. You did HTTP compression, you reduced the payload, all that you have done. From 2000, it has come down to 1000 at the end of day 30, right? In both these scenarios, all your background processes are included. So it's more of a rate. The assumption is underlying software boundary conditions being the same on day 0 and day 30. There's all other parameters being the same. Your rate will help you understand whether you have taken iterative steps to keep reducing your SCI. So in both these scenarios, I mean, this is to keep it simple because, if you have a watt meter, you can obviously measure the power output of your laptop when it was idle and then when you run the software, but that doesn't work for cloud machines. And also bear in mind, in cloud, most of the customers run on, most of the customers run on commoditized servers, but also customer service as well. So in both these scenarios, you will never be able to predict the background processes. It's more the relativity you bring in by keeping both the underlying environmental conditions same. I don't know whether that helped answer that question.
There's another question on the chat. Basically, a clarification required that why do we have R in the denominator? High R would mean a low SCI. Is low SCI pretty good? Is that what's the expectation? Having a low SCI score.
Yes, I think Srini, do you want to take this?
Yeah, sure. So we actually don't have R in the denominator. If you look at the formula, it's basically E times I plus M per functional unit. So it's not, so basically for 500 users, which is R, this is the SCI. For 5,000 users, this is the, so R is more of something that is hovering around the formula. It is not going to be, you won't be able to, because technically speaking, if you think for 500 users, the SCI value is 20. For 5,000 users, it's easy to say it's just multiplied by 10, but that's not how it works. You need to run, because the server utilization, yeah, let me come to that. The server utilization is not directly proportional to the power utilization. It's not a linear curve at all. It's a, I don't know, what is that hyperbole or that curve that I forgot how do you draw it? What is a mathematical notation for it? But if you have an idle server, you will be using like, it's not like you're going to be using 0 watts. And if it's 100% utilization, it's not like you'll be using the complete watts available with the server. So the proportionality principle cannot be applied to R. So R is not in the denominator, it's per R. That's how we call it.
You didn't correct that formula previously, no?
No,
It
that
remained
is
like
like-
that. It looked like a denominator.
I mean,
That's the only thing. Yes.
Yeah, I mean, per, if you speak proper mathematics, right, per is normally a division, but it doesn't mean that if you reduce R, the SCI will be better, because R is not in your control. R is what is R, what is your scalability factors?
Does that then connect to what Kunal was saying, the idea of concurrency?
Yes.
When you have a large number of users,
whatever is your R, it will remain the same.
the wavy current thing instead of an absolute number.
Yes.
So there is some interesting, sorry.
Yeah, sorry.
No, I think you will all be interested. We will love you to contribute. There is some interesting work going on in the SCI open data project. Kunal, I'm not sure whether someone from I think someone from Thoughtworks is only driving it. Yeah, very interesting work where they are trying to formalize what is the carbon emission associated with transmitting 1 GB of data over the internet. How do you quantify it? Because there are, in the SCI calculation today, in the case studies that we have done, we have excluded some of these because we do not know the reference values. So there's one I pasted in the chat, which is also coming out of the SCI open data. For 0 utilization of the CPU, what is the corresponding wattage used? So if you take just this in the x-axis and y-axis and you plot it, that's where I was talking about earlier. It doesn't form a straight line. It forms a ulta line, if you want to call that.
Srinivas, I think you have sent, I did not see any messages from you. You said that you'll be sending the links and all those things, but I don't see anything in the chat. Okay, I think Kunal did it now.
I think Srini by mistake sent it to me directly. So I've just posted it.
Oh, I'm so sorry.
So the message you see from Kunal, right? That is what actually Srini was talking about. Efficient.
Oh, okay. I had by default chosen you as a recipient, Kunal. I'm so sorry.
No, it's okay. It's all right.
This one transaction has X amount of CO2.
I used more carbon in this transaction than.
Cool. I think we can quickly move forward. I think the next question is, we have calculated SCI per hour. What next? What I should do next? We will cover quantifying.
So Okay, so this answer, I don't, I mean, I can't give a definitive answer. So it's right now we are at just like I said earlier, we are at the maturity level where we are trying to compare. So there are a couple of case studies going on in the GSF summit.